what they say about that?
You just have to keep on increasing the level.
And from that way?
But it's through the sound. You see the sound thing? The sound key? You just click on it and just pick it up.
Which is sound?
The sound.
Don't see more than
You touch Y. Okay.
I don't see
Okay.
Western Jamaica. Mona English says that
This one is in Princeton Talks.
Was that a Zenith thing on that?
Where? Right here?
That is a Zenith.
Yeah, I have cars.
Definitely should be the way up. I'm definitely should go up the way up. No. Good luck, should be that. Chris, not the week.
Please, my friend. This doesn't thing have it?
To make sure everybody is set before I send it.
No. This did not get involved.
If anything, I already send it.
Yeah, I mean, what got it right here? So,
Because the assessment, the worksheet,
yeah.
you can always have the questions.
Mm-hmm.
So you can do. I have the email here.
Yeah, you can marry.
And then we're gonna rewrite it based on the assessment.
Yeah, that's really good. Students.
That thing was confusing.
Which one?
Brazilian's got. Oh my goodness, reading it. I'm trying to do the something. Cause she literally put. She's trying to do a half, or a third plus 2/5.
1/5 plus 3/5. That one?
No, it was a third times a third plus 2/5.
1/3 plus 5 is that's one. This one, the
Yeah. I'm like, what is she talking about, yeah? I'm like, you introduced the multiplication before you even talked about multiplication.
Yeah. Mm. I think because she didn't have boys in school, she sees the work.
Yeah, that's what I was telling. That's what I was telling her. I said, she thinks she's right about everything because her children are in school. But no. It's like even Chris was getting irritated.
Yeah, she was. That's what I was trying to say to you last night. You know.
I was telling her, I'm fine with that, right? She's not listening. And then
That's why I shut down. You guys.
You have a screen remote? The other one, with the black one. Mm-hmm.
Right the animals, right?
I see.
Setiano? Morning. I have it. I got it.
Okay, good. Thank you.
I just need to print now. Can I print any print inside here?
But
Is there a print inside?
Oh yeah, that's the problem that they said we have. We are too close to the mic. The only problem is we have to sit back or something.
That's HP 4250.
Because what happens is,
yesterday,
yesterday, when they put her, you see, how they might
Put
get
it on mute. Put it on mute. This is not the, let me see.
I sent it.
she just there.
Okay, so people do. I don't send it again.
No.
Bermuda, did you send me your lesson plan?
We'll send it to you right now.
Okay.
I'll forward it.
What time was that?
Oh shoot.
I sent it like already now.
No, I was missed off the,
That reminds me, I want to see her too. Shoot.
Jamaica campus, are you there? Morning. Morning, what's your name?
Okay.
what you need not done.
Sure.
Lesson you make.
Then I'll come to show.
You can hear them all. You know this in the dark.
Yeah, she's there right there.
Traffic. They put it on 4:30. Wait, 1:30.
I'm gonna, what's her?
WJC,
Yes, Miss. Morning.
you sent a lesson plan for me?
I have it here. Let me send it now.
Please, yes. I want to just print them all.
Okay.
Please search this.
Thanks. We're a little behind time, guys. Almost an hour off. This is St. Lucia. I haven't seen any of your colleagues at Mona's yet, but as soon as I have all three plans, I think I'm going to start.
You have, she said she's going to talk to me. She gets the phone.
I'm just awaiting the lesson plans. Can't start without it. Can't start without them.
You didn't know, Miss Rhea?
I'm listening, I'm listening.
Never mind, I got it.
Oh shoot, where's her? Yeah, that's.
And you changed mom to like teaching. I wasn't trying to teach mom. You were. Let me see.
Yeah.
Like I wasn't trying to teach them. I was just trying to make sure they knew.
Well, my calling is teaching.
Reviewing. And hello. We haven't started yet. We just spoke. We're waiting for everybody to send their budget. So, yeah. I'm looking at it.
Oh, come on.
Alright. Yeah. Alright, I'll see you in a minute.
What were you saying? Olivia?
Okay, so let me look at this.
You don't want to teach?
No, I just wanted them to figure out the sum and just make sure they are following the steps.
Oh,
Like I always feel like I'm gonna say something when I
Come on.
erase word. Because it's on the slide.
Copy, that's what I mean. Copy, copy, copy.
This is what you put in stuff.
Hmm?
This is what you put in stuff.
I don't know saying, oh, I can't see this on my phone. Let's see. All right, let's see how it is. Let's see my fan, for some reason, it's when it PowerPoints, it doesn't do properly.
What? Invalid address? Oh, come on, don't do this.
You want me to send it to them?
Yeah, I tried to send it to you.
Do you know, you have an address?
It is.
What were you saying? That's okay?
Yeah, that's something.
No, not the lesson plan.
She wants the lesson plan.
I want lesson
the-
plans.
The lesson plan, Crystal would have sent to her.
She
You
had,
don't need to send
And,
it.
and
The lesson plan, let me see,
she
look
had
on,
it, she said she had.
look on Crystal's one. And see,
Richard just sent it, right?
yeah, it is, it's a renter's in house. But let Crystal send that.
while I'm at it,
Okay.
I have not got the critique from Bermuda. I have the critique from St. Lucia and
Right.
Western Jamaica.
Did you read one? Read that?
Yeah.
So you want to put some more information in it?
What was the thing that I was looking at? The one see
What is
first.
here?
And then we have to write the last paragraph is we on, and I didn't do it. Areas of improvement and possible alternatives. And I didn't know what to offer for them.
Got it.
So it's really,
I sent it. And now you want me to send you PowerPoint
So
presentation?
you can write right on that, because I'm gonna type it over.
it's a good start.
No, I mean, right, but I'm saying on the bottom, we need alternatives. What, do you know, can you think of any alternatives or any improvements? I like this, put that on.
Remember, students are great. They're not here. I'm going to begin.
Miss Rainford, did you receive the lesson plan?
I'm looking now. Coming as yet.
Alright, morning, Montego Bay.
Not yet.
Montego Bay?
Morning.
Morning. Is the lab tech nearby?
Is there a?
Is a tech person here?
No, I would have to go outside to get them.
Alright. Could you just get them and ask them to call the bridge and enter the session number, please?
Okay, all right.
Alright.
Haven't got it as yet. And I'm looking at both emails. Let's see. Montego Bay, haven't got yours as yet. Are you going to send it? Step out. Myself. No. Really wanted to start at 10 this morning.
See it there for the just sent.
Okay, so here is what I was saying. Right.
Dr. Rainford, you received it yet?
I didn't print it.
On it.
Anyone print it up?
Well, you sent it, I seen it.
Of course. No, I have my portion. Okay, well, I didn't. No, because I was thinking. See,
What is your portion, Crystal?
she's doing the grain teaser, and then I have it doing out with the manipulative.
Okay.
Yeah.
I have mine on your phone.
So like here you started speaking about.
I tried.
I was telling them this. I'm not going to.
The last of the calendar.
I hope that they figured this after they do the copy, this is just to make sure the answer is right. You see what I mean? So I guess it shouldn't be.
Okay, I've got them.
Oh, you got him?
Got them, yeah.
Okay.
I was saying, this last two straight, I just give it back. Quality. I wasn't gonna teach the principle. You know what I mean?
But recalling is a method of teaching.
But I'm not gonna teach it, I'm just gonna say, did you get the right answer, basically?
Okay, you don't have to teach it, but it's there for them to know the knowledge of why they got it.
But the way, I know you changed the word.
Oh, okay, well,
So I can't see, let me see what this is. My plan is a word. Maybe it's a document to go.
okay, which one is that?
That's the first, not right.
So long though.
First slide after the,
The two fractions have the same denominator. In the case of 5, we simply.
but you put it as a definition. So that means I'm gonna define, and I'm not gonna define it. I'm going to say that you
Tech
take this
teachers
principle.
today.
You see what I mean?
Okay.
You see what I mean?
Definition, principle, okay.
Like, see, you see what I mean? That's why I didn't wanna kinda use that language, because that means I'm teaching it, I don't wanna be saying, I'm gonna teach you, I'm gonna say, when you got your answer, did you follow this principle?
But it's the rule. The principle, the rule, the definition is.
Okay, everyone.
Comes up better like this, comes up better like this. I think for my name become. My name will become, and
It's by alphabetical order.
what order was that? It's not alphabetical.
It's not
order.
alphabetical.
What, last name?
Yeah.
It's funny. And it goes back also by last name. Okay, yeah, I can get it like this.
Oh, I didn't put it up front. I always put my name last, because that's the polite way to do it. No, which is last.
Then first.
Politeness is, I go last.
What did you just say?
Under your breath.
See, so
Say it
see
out
how
loud.
you have here, you
I
have.
have never been in this class.
You talk about a comprehensive picture.
I didn't even know. But I didn't write it.
You're in the class, okay. Pernille?
Yes?
You don't want to do.
Do you need the worksheet to be printed?
No, it's not going to be, they're not going to be doing it on it.
Your worksheet?
No,
No, I don't think they need to be printed. I mean, if you put it up after the, if you put it up with the PowerPoint, they can copy it from there. I think that should be fine.
Okay, is there anything that you need St. Lucia to have? That they need,
Can you repeat that?
is there anything that you need St. Lucia to have? That, I need to let them know? And Western
Hold
Jamaica?
on, well, I can't hear you for a second, we just gotta turn up the volume.
no, her volume needs to be turned up, not all.
It's off, you can't hear.
Okay, can we stop being so tense with one another? We have to come together as a team.
Can you repeat?
But I can't work with people that don't touch it.
To St. Lucia and Western Jamaica, do they need to get anything or should I send it to them?
Sure, yeah, you can send it to them for us. Send the worksheet, please.
Send
You
the
can
worksheets.
Yes, just the worksheet. I just sent it. I just sent it.
Your last one.
I need to get rid of this.
see how you were, just, okay, so I'm just saying, see how you were what is unfair times translations. I just wanted to have the word about. But then you have any ideas and came to teach this, they should know this. So that's why the language that we use.
You didn't say this in your email.
I gave you what I wanted in my slide.
Okay, well, let's just
You didn't say this in your email.
What
You
email?
The email you sent me?
then we need this, and we have to work together as a team. So
Why are
let's
you
use-
saying?
Okay, good morning everyone again.
You okay?
I'm fine.
I appreciate what you did.
Okay, but this morning, let me apologize for the late start. Trying to get all the materials together and trying to ensure that we are all on the same page. But we're going to begin. It seems as if this morning we only have 3 groups because I'm not seeing anybody from Mona. I understand that the Mona English will not be able to come this morning, and so they have asked that we have their presentation next Tuesday. So we will see how that goes, but I haven't heard anything from Mona Max. So as it is now, we have 3 groups. We have St. Lucia. They'll be doing an integrated lesson on binary numbers. We have Bermuda, who will be doing a math lesson on order of operations and fractions. And we have Western Jamaica doing an integrated lesson
Dr.
on dictionary
Rainford?
skills and geometry.
Can you
Yes?
turn your mic up?
Can I turn my mic up?
I'm not sure you got it on. Sorry.
Better? Can you hear me better? Very well.
No. Pick the microphone.
Just one?
No, that one. And go to properties. Level.
Okay, here.
Yeah.
You put all the reason on the line.
Sorry.
Can you put it on? Dr. Rainford? Can you talk to us a minute?
Is that better?
No, she's talking the same.
No,
It's hers.
It's not.
Problem.
Are you hearing me? And she sounds the same.
not really. Go ahead. See it. Speak. 74%.
That's not the speaker.
They're not coming. Western Jamaica,
Okay.
Bermuda, St. Lucia.
Yes.
St. Lucia is hearing. Western Jamaica? You're hearing. Okay. So Bermuda, you're not one of the problem? Have you changed rooms?
You just sound very quiet, so if anyone else starts to talk, we can hardly hear you.
Okay, I don't know what the problem is. I'm using my regular voice, my regular pitch, a regular tone. And I'm even moving closer to the mic. You can't see me if I go any further. I'm saying that I'm going to start with St. Lucia and then move to Bermuda. I'm not seeing all the participants from Western Jamaica. I'm assuming that someone is still missing.
Adrian is not here as yet.
Adrian isn't here as yet. Okay, so we're going to go St. Lucia. Alvinus had indicated he needed to leave by 12, so I want to give him a chance to do their lesson first. And then we will go to Bermuda and then Western Jamaica. I haven't seen anybody from Mona's yet, so I don't know if they will turn up. But the English people have said that they are not going to make it today. So essentially what's going to happen is I'm going to allow you to do your lesson. I will manipulate the PowerPoint from this end. So I'm going to have the screen, the camera onto the screen so you all can see what's being said from the various participants. Okay? So
Okay, just before we start, Dr. Rainford,
Yes.
we sent you as well as all the students the puzzle for our starter, and would like to find out if everybody has a copy and if you got it as well.
I have got everything that you have sent, yes. The puzzles.
Yes.
Let me just
Classmates, anybody has the puzzle?
Yeah.
Yes.
WJC, Western Jamaica.
Yeah.
that's the one you're talking. Give me just
Yes.
Yes.
Yeah, that's it.
That's it?
Yes, can we share the screen so that, because I'm not hearing from WJC, maybe they're not hearing me. So we're going to begin?
Just don't go back to.
Yeah, yeah.
Yeah, you said the end of the
You know, the closer,
Yeah.
Is he coming? You're calling now?
You did just that.
I know, he was saying when I came, he was saying you need to call and tell him back because we cannot hear him.
239. I searched you 237 yesterday.
239, what did he get?
4357.
2, 3, 9,
4357.
3,
That's got grades.
5, 7.
Seven. Well, I always got this.
Ready? St. Lucia?
Yes, Miss? Yes, Dr. Rainford? Dr. Rainford? Okay. I think we screened it.
Yes.
That's fine.
Go ahead, St. Lucia.
Good morning, students. My name is Miss Alfred, and with me,
My name is Agnes Melius. Good morning.
and we are here to teach a class in Math and IT combined. Just before we begin, we would like you, while we await the others, we're going to give you 1 or 2 minutes to complete the puzzle that you received in your email. And if you did not receive it, it's on the screen, so you can have a look. Thank you. Western Japan.
They're gonna bring us the speakers, because we don't have any, he said, well, we should have his external speakers. We don't have them. So it's gonna bring external speakers so we can have.
WJC, can you hear me? Or can you see the screen with the puzzle? Dr. Rainford? I'm trying to find out whether WJC can hear me.
WJC, will you respond, please?
We're hearing, but we're not hearing clearly.
So you should just respond when they ask a question so that they can feel that you're a part of the class, okay? They need to feel as if they're speaking to someone. Is there anyone there?
We have a puzzle on the screen and would like you to complete it within the next minute, please.
Okay.
We're doing what is the topic for this class? Ms. Alfred, are we doing what is the topic for this class, worksheet?
Yes, that's a puzzle. So on one side you have the indices, and on the other side you have the equivalence, the whole number equivalence, and letters next to it. So you find out what is the whole number equivalence, the letter which matches to that equivalence, you write on the line.
Can I take a guess?
What's that?
Can I take a guess what it says?
What?
You'd
What
like
the
to
puzzle
read the
says, can I
directions?
take a guess? Miss Alfred, can I take a guess at what the puzzle says?
Oh, you want to guess?
Yeah.
Sure, okay.
Okay, I think it says binary numbers.
Okay, good. And why would you think so?
Beg your pardon?
Why do you think so? Why do you think that's Did you work out
Why?
any of their equivalences?
I would say I've used binary numbers before, and yeah, this is 10. So this is I.
Okay, well, let's just give the others a chance to complete 30 seconds, and then we'll begin our presentation. Dr. Rainford, is it possible for us to get the screen shared so that everybody can see, instead of seeing me for now, when I'm ready for them to see me, I will ask to go back. Because we're not seeing what they're seeing.
The screen is being shared, I think. They tell me it's being shared. Miss Etiana.
All right.
Okay, now I'm seeing what they're seeing. But we can see the screen clearly. Ali?
For speakers?
Yeah.
Yes.
So,
All right.
Okay, good. Students, your time is up. Crystal, were you able to work out the puzzle?
Ben? Big Ben? Really, I couldn't get it. I'm sorry.
Crystal?
Okay.
And?
Rosina? Bermuda?
I'm sorry, we cannot hear you. You have to ask the question again, please.
1 second, me a minute.
Just asking
But
if
just IT coming. The IT is trying to hook up some speakers so we can hear you.
One moment.
And 100. I don't know. That's how you count?
Which question is you asking, Ms. Alfred?
Okay, I was just asking if everyone was finished with the puzzle so that we can begin.
Yes, we did complete the puzzle.
Okay, Rick, what did you get?
And?
We got binary numbers.
Okay, thank you. So we are going to, my next question to you was that were you able to see the screen?
Agent, come here, you do it, yeah.
Were we able to
The
see?
PowerPoint. Are you able to see the PowerPoint or are you saying
No. Oh. No.
I'm not screen now.
No. Someone in Mona has to talk in order for the screen to go to the screen.
Because right now we're seeing rest in Jamaica.
We are ready to begin the PowerPoint presentation. Can you see it now?
Yes, we are seeing it. Binary number.
Please.
All right, by this point, all of you should know that we are discussing binary numbers this morning. We are going to look at several things about binary numbers. We are going to begin.
So we got a volume control here. And when you guys finish up,
Excuse me, I'm getting a lot of feedback. If you're not asking a question or making a comment, can you mute your mic, please?
no, you can shut up.
Avinos,
Yes?
or teachers, we're not hearing you well.
You're
I
not
don't know,
hearing
we're
me
just
well?
not. You sound far and muffled. I don't know. Are you close to the mic?
Very close.
Oh, Lord Jesus. Alright, we'll try and listen a little harder.
Can you turn up your volume?
No, it's all at the top.
Wow.
Meaning you can't. Okay. I don't know what's happening. Some interference. I don't know.
Can you turn off your cell phones, please? Turn off the cell phones.
All right, can you hear me better now?
Yeah, that was very clear a while ago.
All right, great.
Hope it stays
So we
like
can
that.
continue.
Okay. Yeah.
Yes, thank you.
All right, so everybody can see the PowerPoint presentation, right?
Yes, we can.
Can everyone see it?
Yeah.
All right.
We can't see it.
No, we see you.
Can you see? All right, so everybody can see, so great. So I was saying by now you would know that we are discussing binary numbers, and we are going to look at binary numbers both from its importance in math as well as its importance in computer systems. So we are going to look at conversion between decimal, which is what you already know, and binary, which may be new to some of you, and conversion the other way, as well as the use of binary numbers in computers. Now, in order to go into our topic this morning, I have a video that I want to share with you. This video discusses the computer and the computer language. I want you to watch the video and pay close attention to the various terms that are used. So can we have that video play? The video is on the second slide.
Alvinus,
Yes?
we didn't only see his shoe, unfortunately. We can't see the actual slide.
That's what I'm saying here. So we need the screen shared.
Well, we need the screen to be shared. Can we have the screen shared?
Not just the just to understand but share this.
Dr. Rainford?
I'm trying to get them to I'm coming ambulance. Let me just
Yeah,
let me get. You're seeing it now.
Yes.
All right. Let's go again then. So this is the video that needs to
This
be
is the
shared.
video, yeah.
All right. Let's go.
Can you play the video? So you will listen to the video class, pay attention to the terms being used.
Okay, talk, Miss Rainford.
I'm not hearing the sound on the video.
Is everybody hearing? Because I'm not hearing.
Alvinus, you can't talk or it's gonna change to you.
That's why, yeah, go ahead.
Just let Myrna talk and it go to them.
I cannot hear you clearly, Bermuda.
If Myrna talks, then the big screen will go to them.
In the early days of computing, there was a language barrier between computers and humans because you had to use machine language if you wanted to talk to the computer, either in binary code or its exact English equivalent. This was very slow and laborious. Every time a generalist wanted to tell the computer to print something, or make a decision, or repeat an operation, he had to break every statement down into tiny electronic steps. The same for the mathematician who had to translate all his math symbols into long-winded computer talk. And even the businessman who just wanted to do payrolls and inventories and make out bills to his customers had to spell everything out in nitpicking machine language. But eventually, after a number of years, people began to realize that they were translating the same fundamental ideas into machine language over and over again. So they made lists of the instructions and symbols and procedures that each of them used most frequently.
And they call these lists high-level languages.
For example, BASIC for generalists, APL for mathematicians, and COBOL for businessmen. And then they prepared automatic dictionaries, which,
just like English-French dictionaries,
contain
a list of all the vocabulary
of the particular high-level language in one column with its machine language equivalent in a second column.
Okay, thank you very much. Thank you. Can we move to the next slide? Okay, so let's discuss this video. What is the name of the language that the computer uses or the computer speaks?
Binary codes, I guess.
Can you repeat that, please?
Binary code.
Binary code. Thank you very much. So this is one. Can somebody else give me another name for that language?
Kobo?
No, not quite. There were at least two names that were mentioned.
Is it the basic?
Can somebody from Jamaica, if you heard the video clearly, can somebody from Jamaica, from Mona?
We saw basic. I was like, applicant, that was the last thing.
No, I just know one. I never hear the other one. Yeah, I didn't hear the other one.
We're guessing. Give me something.
I know nothing about mathematics. Can we get a clue? Something?
Yes, can we get a clue?
What does it start with? Something?
It starts with an M.
Start with an M?
M.
M. M as in mother.
I didn't hear that one at all.
Huh?
I didn't hear that.
Wanna know?
We give up. We.
Okay, all right, nobody caught that. But what I was looking for was machine language. Because binary code is also referred to as machine language. Okay, you heard that, right? In the video.
Yeah, we did, yeah.
Okay.
Okay, all right, thank you for trying. I want you to look at the picture on the slide that we're on, the slide of the questions, and you can see some digits, image of a computer. What are these digits?
0 and 1.
Yes.
0 and 1. Okay, very good.
0 and
Now
1.
we're... Very one? Okay, so you only see zeros and ones there. Okay, very good observation. Is there a prefix we can use to represent the word two? Is there a prefix we use for two? By. Thank you very much. You're doing very good so far. Right now, I will hand over to Christiana.
Okay, students. You will also send a sheet with some pictures of blocks. Anybody has that?
Yes.
Okay, great, Bermuda. Thank you. So we're moving to the next slide, which is our activity. And what I wanted to generate is to ask you, can you remember, say for example, we have number 123. What was the place value of the number 2? What was the place value of the number 2 in 123?
What is it?
What is the place
Could you
value?
Oh, what is the value?
In the number 123. Okay, so we can't remember. But okay, so if we have 123, the number 3 stands for 3 what?
Ones.
3 1, good. And then 2. And then 2 what?
Tens.
2 tens, great. And then 1.
100.
100. So if you can see me, we have the 100.
Got it.
There's 10 and 1.
Okay.
That you have cut out. How many single blocks will you use for 123?
How many single blocks will be used for 123?
3 single blocks, then so we have 3 of these. Then how many do we need?
2.
2 tens and then
1.
1 of the
1 of the hundreds.
1 of the 100. Now if I had just the number 23, how would I represent that in my block?
2 tens for 2 and 3 units.
And
3 unit blocks.
2 of the 10 blocks, and if you have your block with you, you can group it. You have 2 of the 10 and 3 of the
Ones.
Okay, great. So we're moving on. But sometimes we have this frustration because we have a computer, but we don't know how to get around it because we are using tens, hundreds, thousands to count and to, if we're using numbers or we use letters, but the computer is in a totally different language system. There's a language barrier, and we need to have that connection. So what is going to happen is that, Lola, can you move your mic, please? I'm hearing the truck. Good, thank you. So what is going to happen, students, is that you will have a repackaging of the numbers. So if we have number 23, we are going to repackage it. And so to understand repackaging, we'll go to the next slide with some bottles. Can you see the slide, Bermuda?
No, we cannot see you.
Can we have this screen shared for now so that Bermuda can see?
You share the screen? Bermuda can't see the screen.
You see it now. You see it small.
Dr.
And you see
Rainford, we have the screen so that they don't see me when I'm talking, they just see the screen.
Everybody else seen it except them?
WJC, can you see the screen? Bermuda,
Yes, we can. Yes.
Okay,
Yeah.
fine.
Okay, so we have bottles coming off of the line, and they're coming one by one. And if we want to package them, we can package them in groups of
I think that's
4.
groups of 4, or we can also package them in groups of
Can't see, we see you.
6.
Bermuda keeps saying me.
I don't know why Bermuda keeps on singing.
Yeah.
I have no reason, I don't know.
Okay.
Why is it that they keep on seeing, the screen keeps on moving?
Because for the last class we had, when we were doing the microscope, there was something that was being done where the screen was shared totally. Like,
Yes.
they could see just the screen and me. That's what we did the last night first teaching we did was,
Do you want to take it off record? Because when it records, it does that.
Is there any way to not allow the screen to? So they need to see the screen permanently. Yeah.
When I send content?
I don't know.
Oh, you mean when
Yeah.
someone speaks, it also.
Right. That's not gonna happen?
But it should show, I don't know how your screen is, but it should just continuously show us in one box with the content.
Yeah, but Bermuda is not seeing the screen.
whenever I talk, there will be something. Okay, I think it's gonna work this way. Bermuda, can you see it now?
Said Lucia, see.
Bermuda?
I see, well, we see small PowerPoint in the corner, and we see Christiana.
Yes. But
If
I
you
want
switch while she
to
goes in there, now we got it.
Okay, I guess I'll continue. So we have bottles being packaged in sets of 6. Or we can have them in sets of 12. Okay, so I want you to get out your binary blocks now. Can everybody get the binary blocks that I asked you to cut out? And we have the numbers.
It's the number one, I got it.
You have the binary block?
Yes.
Okay, so in the binary block, you have singles. Can you see that?
Yep.
Then you have those in groups of 2.
Yes.
You also have groups of, what's the next one?
4.
4. And the next one, the 4th one, groups of
8.
8. And the last one, I think you have is groups of
16.
16, great. Okay, and what I noticed about this usage, what are we using? It was in your introductory activity.
Yep.
Remember your puzzle you just did with the number 2, 4, 8? What is it?
It's counting in binary.
Not really, but the powers of
2.
1 of 2. Good, powers of 2. Okay. So say for example we had the number 23 and we wanted to package in groups of 2. Which of these would be the largest amount occupied in number 23? It would be the 2, the 8, the 16. What is the biggest amount? The biggest grouping of 2 I can get is number 23. If I have the number 23 and I want to package it using groups of 2, I can use just 23 singles, but that's going to be a lot of little blocks all over your desk, right?
We could use.
I have the number 23 and I want to make groups of 2. I want to represent the number 23 using the blocks that you have.
You can use one of these 16 blocks.
Good, stop. So we can use one of the 16. Very good. Now we have one of the 16. How many blocks are we missing to represent? We have 23 and we have packaged 1 in a group 16. So how many we have left?
7 left.
7. So can we make any groups of 8 with the 7?
You can take a 4 block.
If we have, just wait, you're a bit fast. Let's let the others be perfect. Okay? So if we have 7 blocks, can we make any groups of 8? More? If we have 7 blocks, can we make a group of 8?
Repeat that again, sorry.
If we have 7 blocks to represent, can we make a group of 8? Is it possible to get a group of 8 out of the 7?
That's too much.
Is that a trick question?
Is it a trick question?
Well, it's a yes or no.
Seriously?
It's a yes or no.
Miss, teacher, sounds like a trick question. No.
So I'll give you your answer, yes or no? If I have 7 items, can I equal 8?
No. Let me say no.
Thank you. No.
No, but it sounds like a trick question.
Can I make a group of 4?
Yes.
How many groups of 4?
1.
How many left?
3.
3. Now, with that 3, how can I package it?
The 2 and the 1.
1, 2, and a?
1 single.
A single.
One
Thank
unit.
you, Rainford. Very good. So we're moving to the next slide. And what we just did was to convert the number 23, which was a decimal, to a binary number. And we're going to go over that. Can I see the screen? I'm not seeing the slides. I'm not sure what you have, what you can see.
Trying to get it for you, Christiana.
Okay, so we're moving on. Okay, Bermuda, let's look at the screen. So first, we're going to go one at a time. That is one for me, please.
Can't see this.
Can't see the screen, Christiana, sorry.
I'm so sorry.
Can you zoom it in?
Alright.
Can you see?
It says decimals to binary conversion. That's what it.
2 to the
Binary conversion.
2 to the. It shows 2 to the 0 power. Can you see that, Rainford?
2 to the 0 power. Yeah, I can see it.
And what's the value of 2 to the 0?
1.
1. Okay, so we can click that. We can move on.
2.
2 to the 1, and what's the equivalent? The whole it's 2. Then
That's 4.
1 2 squared 4, and then 2 to the third power.
8.
And 2 to the fifth power is
16.
16. Great. Now remember when we have the number 23 and 2 to the fifth power, sorry, we have 32. When we had the number 23, did we have any groups of 32? I'm so sorry for just advance. Yes. Did we have any groups of 32?
No.
No. So we put a 0 under the 32. And did we have any groups of 16?
Yes.
How many groups of 16?
1.
1, okay, so we have that. Any groups of 8?
No.
No, so we put a 0. Any groups of 4?
Yes.
Yes, how many?
1.
1. Any groups of 2?
Yes.
How many?
1.
And a single? Yes or no?
Yes.
Good. So what we just did was to obtain the binary equivalent for the number 23. And so we have 23 to the base 10 is the same as 10111 to the base 2. Is that understood?
Yes.
Okay, so we'll turn to the next slide. What is the decimal equivalent of the binary number 10100? Now, for this case, I want you to use your blocks again. So, the first 0 next to the 2, the first 0 says we have no singles.
Right.
The second 0 says we have no groups of 2. So we have none of these. But then we have a 1. What does that 1 represent? We have one group of what?
4.
One group of 4. And you can use your blocks together with me. One group of 4. Any groups of 8?
No.
No. Rosina, you following with me?
Yeah.
Okay, so no groups of 8. And any 15?
Yes. 1.
160. So if we count using the block, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19,
20.
20. So that binary number I just gave is the same as the number
20.
20. Great, thank you.
Oh, wow.
And we will see that in the table again. So we can move to the table.
Want to go back and you mute your mic, please?
Thank you.
Thank
Okay,
you.
thank you. Okay, so we're going to the table, and the first entry we have is, remember, the number that I gave you to convert was 010100. That is the binary number that I gave you to convert. And what is the first power that we're going to look at is 2 to the
0 power.
0 power. Rick? What's the next one, Rick? After 2 to the 0, what do we have after 2 to the 0?
2 to the first power.
2 to the first power, then Rosina?
Yes. I don't have the here you have one.
Following with the slides. Can you see the slides?
Oh, I see, yes.
So the next one will be 2 to 7.
2 2 7.
So okay, 2 to the second, then Crystal?
I actually said that, but I'll do it's 2 to the third.
2 to the third. 2 to the third. Because we're doing binary and
Right.
the word by stands for 2, we're using the powers of 2.
2.
Okay? And the last one is 2 to the 6th power. 2 to the 4th and then 2 to the 6th, sorry. Okay, and if we go over the equivalences quickly, we know that 2 to the 0 is the same as, what's the whole number equivalent of 2 to the 0?
1,
2 to the first power,
2,
2 squared,
4,
2 cubed,
8,
then 16, and the last one would be?
32.
Great. So if we just remove the second row for now, so we just press the button, all right? The second row just goes away. And so we have numbers here that we are going to actually group. And so it would be 0, 1, 0, 2, 1 group of 4, no 8, 1 group of 16, and no groups of 32. So we can work
Can we
this
see
out.
it? Because we can't see it. Unfortunately, we can't see it.
Okay, I'll be quiet and then maybe the screen will come up.
Up a little. Can you see now, Bermuda?
Yeah, is it supposed to be the next slide or this slide right here?
Same slide at the bottom.
Oh, no, we can't see the bottom. Sorry.
Kick
We
the
have
slide
to
up a
bring it
little.
up for Percentiana is.
Bring the slide up a little. And it can
Yeah, we can see it. Yes.
Go ahead, Christiana.
Okay, great. So we are now going to look at how does this computer use this binary code and the binary numbers that we've just converted from our language to the computer language.
All right, class. So you may be wondering how we make use of all of these zeros and ones on a computer. Okay, and now we're going to discuss it. We use binary on a computer for basically 3 things. The first one is to represent data. This is the primary use of binary in a computer. The second one is to communicate. And the third one is to manipulate data. Okay, so these are the 3 things that we generally use binary for on the computer. Now, when you go on your computer, for instance, this morning you may have gone on to check your email to see what handouts were sent and so on. You will not see ones and zeros and so on. You see things that you can understand. You see letters and characters and so on and so forth. Okay? So how does the computer take these ones and zeros and give you these characters that you saw in your email this morning? Okay, if we go to the next slide. Okay, on the next slide, discusses that a little bit further, how the computer uses it a little bit further. It says the basic unit of storage in a computer is a bit. And the word bit stands for, is a shortened form of binary unit. Now, we discussed binary units a few minutes ago, okay? And the binary units are ones and zeros. And that tells you that a bit is a 0 or a 1 on the computer. Okay? We advance to the next step, okay? 8 bits 8 of these binary units make 1 byte. And you can see there's a little diagram that points out a bit there, the 1, and it shows you that these 8 bits make 1 byte. Okay? Now, there are several ways that we can represent several what we call schemes or standards for representing binary code, and one of them is what we call ASCII. Can you see that?
No, unfortunately we can't, Elvis. Yeah.
Beg your pardon?
We can see it now. It's shared screen. We can see it now.
Okay, can you see that term ASCII? ASCII.
Yeah.
All right. This term stands for American Standard Code for Information Interchange. So it's an acronym. Okay? And what this does, it uses 2 representations. It uses decimal values. Decimal is what we use in everyday life. It uses decimal to speak to human beings. And it uses binary to represent what the computer has to deal with. And we are going to do a little exercise where we are going to look at how the computer does that. And in your practice worksheet, if you turn to your practice worksheet, on the page before the last, or the last page, I think page 3, there is a table there. And I want us to look at that table. Can you see that table?
Yes.
Okay, it says ASCII code. Okay, on that table, the column that's in bold, these are the characters on your keyboard. Okay, the bold colors, the bold columns. So you have 1 to 3 of them. It starts with blank, and you see some of your punctuation marks and brackets and so on. And then it goes into capital letters, and then it goes into lowercase letters. Can you see that?
Yeah.
Then you will see groupings of numbers. There are 3 columns of numbers as well. The first set of numbers are binary code. By now you should be able to identify that. And those in parentheses are the decimal values. So I just want to make sure everybody can identify that, because we will need to use this table for the next exercise. What does what does 33 stand for?
Just say that again?
33. If you look at the table, what does 33 stand for?
The exclamation mark.
Exclamation mark. Okay, thank you very much. What does 108 stand for?
108. Letter L.
Yes, very correct. Okay, thank you. So I can see you know how to use the table. Now, if we go to the next slide, on the next slide, we have an example of a message that's coded.
Can we see the slide, Elvis? We can't see.
Oh, very sorry, my apologies. Back to the slide.
Right. That's it. Thank you. All right. So this slide has a message. And I want us to attempt to decode this message using our table of ASCII codes. So what we are going to do, we are going to look at each grouping of binary code. You'll notice that they are placed in groups of 8, each one representing a byte. Okay? We're going to look at each one, compare it to the table and identify the letter or symbol or character that should be there. I want you to try this one. I'm not sure, but I want you to try it because we're running out of time. So can you try to decipher? I'll give you 30 seconds to try to decipher the message on this slide.
Right, that's just really computer.
All right.
All right, does anybody have the first letter yet?
The first letter I have I.
First letter. Double check that, please.
It's a capital I or no?
Look at, compare what's there to what's in the table.
That's wrong evidence. The first letter.
Everyone?
Correct. Oh no.
You're not seeing. Can we move the camera a little to the left? We're missing some digits.
Okay, can you put that one up on the screen? Because I'm doing the one that. Ms. Rainford, can you put that one on the screen? I see evidence. I can't see that.
You can't see the first one. It's
no.
You're not seeing the screen?
I see it, but not clear.
You can't see clearly.
Yeah, if you switch, because I see you, but if you switch the screens and put the screen up, I'll be able to see the screen.
Yeah, I think what you want to do is to reverse.
Yeah, go over just a bit. Left, go to your left.
Oh, we have a computer, because this is just too much numbers. Oh, we have a computer.
Go over to your left. I can't see the beginning.
Sounds like the beginning. So I think it's to your right, actually. But then if it comes at the beginning, it's a screen, it's a part of the left. Move it down.
Oh, go. Can't see. I can't see.
I'm still not seeing the entire. Can we zoom out so that we can see?
No.
No, but when you shift it that way, you're cutting off part of the message. Can you see Bermuda? Can you make this out?
No, I see you. We see you, Alvin.
Or can we zoom in but go to the opposite side from which you were going a while ago? Alright, can we zoom in on the first set of characters? Even if they're not seeing the bottom, but at least if they can see the first, then the second, and so on, and that would really help.
What we have is totally different from what is in the board. That's what I'm saying. That's because I got the first letter.
I'm got the first data, but I'm going to
All right,
the third data.
I
I can't even get to the third data.
capital T.
not the capital, that's right.
After the
Like
word
that?
coding, after the word coding, there's a 0100. Can you zoom in just on that so that you only get a few of these so that they could take it one step at a time instead of trying to see everything?
This one. Zoom in on
Oh,
this.
just zoom in on the
Yeah,
first
zoom in
one.
on this. Sorry.
Go over.
Yeah, zoom in on this.
I found it.
You can see that
Yeah.
01. Yeah. No, too much.
You're making me put my glasses on now.
The first letter is
That is
A.
good. Thank you.
Glasses and apostrophe.
Yeah, definitely.
All right, very good. Let's go to the next one, right next to it.
No, this one is 11.
Move into the space. I don't want to see any part of the foot. Right.
Next one is,
Which one are you on?
that's the next one.
Which one? It's, got the first sentence. First word is it's.
No, this is a different, that's what I'm saying, this is a different one.
The first word is it's.
It's? No, I think you're looking at.
I-T apostrophe S.
But this is different.
No, that's in the handout. We're not looking at the handout.
Handout, yeah, we're looking at it in the board.
Oh, okay. I started with time.
What's on the screen and what's in the handout is different. Okay, so
Okay.
sometimes
100. Okay. 100.
That one is, I want to say lowercase l.
yes, lowercase l. Can somebody from Jamaica tell me what the next one is?
Don't go by.
Go to the other one.
Muna.
Right.
That's what they got.
That would be, beg your pardon?
That's lowercase l, right?
No, they.
All right, yes. So what's our first word, Western Jamaica? Did you respond?
I did.
I just thought we called it.
All right, Western Jamaica doesn't seem to be hearing me. Can we move to the next line, please?
Down below.
Down below.
Yeah. And over to the other end. Other end. That one right there. I don't have a worksheet.
Like it on blank. That's it.
Well, I start from her solution, solving equations using that.
No, I'm printing this up. Can I get it to you?
That's the next line, Alvin.
Yes, let's try to move a little faster.
0, okay, 0, 0.
That's a blank. That's a blank.
Yeah, not the blank, the next line.
Okay.
Demand on things covering it. There you go.
Yeah, right there is fine.
Remember, there are blocks of 8. So where you see the space between them?
Hello, 0.
No, figure.
It's 0.
Ah.
0, 1, 1.
0, 0. 1, 1, 0. That's what it is.
0, 1, 1, 0.
1, 1. That's right. 0. That's an 8. No.
Something's missing. Hello.
0, 1, 1.
Oh, that's the
0,
same one we
0.
just did.
1, 1, 0. That's not it.
Let me see. Where you found it?
0, 1, 0.
Or anybody else again?
Lowercase f.
Lowercase f, yes. Let's move to the next one.
F.
Next
0,
grouping.
1,
Can you bring it down, Sam?
0.
Not down to the.
Open with the big screen. Okay.
0, 1, 0.
And then 0, 3.
0 or O.
Yes. It's an O.
All for.
Alright. So I heard somebody saying all for. So we already decoded 2 words. Kind of.
0, 1, 1.
All for.
0, 1, 1. All for. I suspect it's all for man, right? That's I
Who is
guess.
that you?
I guess I look man, but I'm not check. 0, 1, 1. Yeah. All
Who
for
is that you speaking?
Yeah, all for love.
All for love. Very good, very good. All for love.
He gets to tell me that he didn't.
No, but let's do the LO and I'm going to say I must have.
Okay.
I never check my
We're able to decode a computer message, and it looks like that when it comes to love, you have to work very hard. Okay? All right. What we're going to do, so it was also love, we were supposed to do an activity on the sheet, but what will happen, the sheet that you have, this will be your homework for the next class, because our time has quickly run by. So we are going to go to our last slide. Okay, we're going to go to our last slide. Thank you very much. So we are going to consider what we have done for today. And I want you to write in 1 or 2 sentences, not more than 2 sentences. I want you to respond to the statement on the slide. Think of what we have discussed this morning, and then you will tell the class briefly what you found most important in the lesson, and you will say why you felt it was important. So I just want not more than 2 sentences. I'm giving you 1 minute to write 2 sentences.
Alvin, do you have to write these sentences in binary numbers or just write the words out?
Revan?
We have to write these sentences in binary numbers or write the word out?
No. If we're supposed to write a message in binary numbers, that was
No. It's English.
All right.
Normal standard English. If you give me binary numbers, I will ask Rick to decode it for you.
but
Can I try, sir?
she did.
Can I go?
Yes,
Is it
go
10?
ahead.
All right. For this class, I found out that it is important for you to know the place value of the strings of zeros and ones, or else you will not know what number is supposed to be the final number.
All right. Very good. Very good. Thank you.
While we were there, we're gonna ask the student next to you what she wrote on her reflection.
Who's that?
You still gotta write your reflection.
Oh, I'm sorry, I missed it. So she machine language. I know we learned machine language is a language and binary numbers. I'm talking for Crystal. Machine language and binary numbers are used for computers. It's the language that computers speak.
Okay.
All right. Very good. Very good. Can we get somebody? Is that all? You were not done?
Yeah.
All right, so since you did a lot of you very participated today, so let me hear what you found important.
I must admit, it was very refreshing because I remember doing binary numbers a long time ago, and I still sort of remember how to count in binary numbers. So, Alvinus, I'm not an IT person, but strictly mathematics, so I enjoyed the binary activity and yours, Christiana, trust me.
You need to tell me
Huh?
You in grade 9, wasn't it a long time ago?
Yes, a long time ago. Very long, very long. I may look young, but I'm much older than I look. But
Okay, thank you.
It was fun. It was a pure memory that I had to record on.
All right. Thank you. Thank you. That's good. Can we get somebody from Jamaica? Is Robin in class today?
No, Robin and Gavin are not here.
Okay. Animal, I guess you came in for the latter part. Jomo, do you have any reflections?
Yes, you could say that binary operation as real-life application, for example, in using it in the language of computers.
Okay, so will this change the way you look at computers?
Is that real? I would say more change the student idea, perception towards binary numbers. When change the student perception towards binary numbers, the student will not feel like the teacher is just wasting time with him. He has a real life application to use it.
All right.
Thank you. Any questions for us at this point?
I have a question.
Go ahead.
All right. I was looking. I saw where the 2 and the 0. How do you call that? 2 to 0.
2 raised to the power of 0.
Yes, that one. All right. I saw where you had like a row, a row of numbers, and under it you had like, I think 1 at one point, and then the other time you had like 2 at the other point. I was a little confused with the 2, and because I don't know when yes, just go back, I'll tell you. I don't know when it's worth 2. It's worth 2. Like right there, I see 1. 2 to the 0, I see 1.
Yeah.
In the red. And then and then at another time, I see like, I can see where the logic is when you say maybe 2 times 1 is equal to 2.
Yeah, she's okay.
But I don't know
No,
why.
oh, sorry. Okay, this would be based on your prerequisite knowledge, but then what we're trying to say, 2 to the first power doesn't mean 2 times 1. It just means you have one group of 2. So 2 squared would be 2 times 2, so it's 2 sets of 2. 2 cubed would be 2 times 2 times 2. So we have 2 3 times.
Yes.
It's not 2 times 3, but it's 2 times 2 times 2, which is 8.
Yes, I understood that part. It's just that I can see the logic down that side. I just don't know I don't know how the 0 goes up top.
Or the 2 to the 0 is the standard that any number to the 0 power would be 1. So 10, if you looked at your calculator,
Yes, that's what I was
10 to the 0 was 1, and 2 to the 0 is also 1. Okay?
Okay.
Times 0.
I think it doesn't work like that, Regina. I think we're just maybe down to this one.
We're not using the 2 times the power. It's grouping.
You don't understand how 2 0 is 1. Cynthia.
Hi, Kizia.
Hi. No, I was just explaining why they're having an issue here. They don't see how 2 raised to the power 0 would give you 1, or actually any number at all raised to the power of 0 to give you 1. That is the problem that they are having.
That's what I'm asking.
That is it. We don't understand that part.
That's a rule that can be proven, but
Does it mean 2 to the power of 0? What does it mean exactly? Because we are looking at it as 2 multiplied by 0.
Because I see 2 multiplied by 1.
But what I'm saying to you is not,
But
we're
2
not
times
using
3 would give 6.
the power is not being multiplied by the base. It is not 2 times 1. Okay, 2 times 1 is 2, but that's just by coincidence. But what I'm saying is that the power tells you the number of times you're multiplying the base by itself. So 2 squared would be 2 times. 2 to the 4th power would be 2 times 2 times. So it's not, it doesn't have the 0, it doesn't tell you 2 times 0.
Okay.
There's a difference between just normal multiplication and the 2 times table and powers of 2. There's a difference.
You have to show them the indices.
Okay, miss.
Okay, I guess next class I will have to prepare the proof for you and then I'll present it to you, okay?
Okay, thank you very much, class. You're a wonderful class.
I think there were 2, and I thought you were good teachers. Thank you, St. Lucia. Western Jamaica. I hope you got that.
Yes, miss.
I hope you got at the end that 2 raised to the power of 3 does not mean the same as 2 times 3. 2 times 3
No,
is
no,
6.
miss, we understand down there, miss. They're like 2 times 2 times 2. So it is really, it's just a 0.
This is a rule.
It's a rule. Okay.
It's a rule. Anything raised to the power of 0 is 1. So if it's 2 to the power of 0, it's 1. If it's 10 to the power of 0, it's 1. You get it? It's a rule. The rule can be shown. It's one of those rules that can be proven mathematically. But they are not. That would now take you into deeper maths. Okay? But we take it as a rule. But 2 times 0 is 0.
Yeah, that's what confused us.
Yeah,
That's
2
what we were
times 0
doing.
is 0. But to the power of 0 is 1.
Oh my gosh, I was like, okay.
Alrighty, okay?
Alright, thank you. I learned something today.
Exactly. I'm so happy. Alright. No, that was quite interesting, and I'm happy to see that you were able to integrate. I was thinking, St. Lucia, that one of the things that you could think about doing, let me just one of the things that you could think about doing as you think about going forward to your evaluation is you may want to think about the process of integrating the lesson. How it is that both of you, for the considerations that you had to bring to bear to get an integrated lesson as you did. Just a thought. You don't have to use this slant at all, but I thought because you were put in a box, so to speak. I had to you deliberately you had to work together, and you did a pretty good job of it. Maybe you want to say a bit on that aspect for part C of the assignment. Are you with me?
Okay.
But that's just an idea. You don't have to do that. You could go with what you had intended. All right? Okay. Okay. We're gonna go now to Western Jamaica. But no, not Western Jamaica. We're gonna go to Bermuda. I have not yet seen Adrian. So I'm gonna go to Bermuda for their math lesson. And hopefully by the time we're finished, you perhaps have to take a break, and then Bermuda WJC will come in the afternoon. Okay? Is that okay?
Yes.
That's fine.
Okay, so I'm going to bring up the PowerPoint for
I was just
Bermuda.
going to tell you, Rick just had to step out on, he had an appointment he didn't realize. So we do apologize if we sound like we're improvising, because someone's gonna have to take Rick's place.
He coming back?
Yeah. He is coming back, but he had to rush out because he had an appointment he had forgotten about. Can we take lunch now?
Rather that we break now then? And wait a bit for him to come back?
That would be kind if you could.
Okay, do you know how long it's going to take?
Well, if we, during our break time, we'll go through his part, just so that it could be a smooth transition. So if he comes back or not, we'll go through, because we each have our own part, so we haven't gone through his part.
Okay, well, let's take 15 minutes.
Okay.
All right?
Yes, thank you.
Okay. And WJC, can you see how far Adrian is, please?
He just called to say that he was in a meeting and it's finished. So he's probably about 10-15 minutes away from us.
Fine. I don't know. Do you have one?
No, I didn't.
Okay, fine. No. If you don't have one.
No, I can get it. Yes. Some small paper and a control thing. I'm not sure another seat. I'm not sure that they use something like attached to it like this.
We might have to use.
Can you, if you write on the board, can they see it?
Yeah, I'm gonna see it that way.
So can you represent that in any way on the?
Yeah, we can just draw a square and draw.
You perhaps can do it now. Right?
Dr. Rainford?
Dr. Rainford?
I'm here.
Yeah, we're on break.
Yes. I said that I would give them. Rick had to step out.
Yeah, but
Step out.
I may have to leave now, you know.
Yes, I remember you said you had to leave at 12.
Yeah, it's 6:12 right now.
Yes, I know.
Yeah, so I'll see you on Tuesday?
Yes, you will.
All right.
And what I may do is, I know that the English people will do their session on Tuesday, depending on how this afternoon goes. I hope Mona will do theirs as well today. So we'll have one lesson postponed for Tuesday. Okay? You got that? No, what I'm saying is that the English group at Mona, they are not going to present today.
Oh, okay.
They have asked to be excused. So what I'm going to do, they will have their presentation on Tuesday.
Yes.
And but we had a break because Rick went out. Rick had an emergency. So I'm giving them some time to go back over their presentation without him so that they can present.
Okay.
So I took the break earlier.
What else is going to happen on Tuesday since I won't be there?
I'll be looking at assessment.
Okay.
I'll put the PowerPoints up so you can have a look at it.
Okay.
All right?
All right, thanks.
But the class should be recorded, so you should be able to see it.
We still have not gotten the recording from the day that we were not there.
My understanding is that they should be up. I was checking this morning, but I had a problem with my ID, so I have to change my ID and then I go on. But I understand that they should be posted. So you could check to see if they're actually there. I have not been able to do that.
Okay.
All right?
All right.
That good. I think that's good. And just cut up 6 small strip about that length up. I don't put it at
Let me see the length of it.
no, that makes it need the width.
Yes, because I don't need them small.
push it to one side. Oh, so you want this small unit, and you want to use a different color so that you can see what you see.
In my content, I place the activity and the skills. But I'm seeing where there's another heading that says gender and activity.
That's just general. That's just
Sentence.
yeah. It's just a name.
Just a name.
Yeah. Up front.
Alright. So that is not the method.
Oh gosh, what charge for this?
How they gonna charge you?
It's 20 cents a sheet.
No, it's not. You get a certain quota for a month or something like that for students.
Okay, listen.
You can't just say, okay, Racina, that is the case. What do you think I got the number for?
Bermuda, are we ready?
Yes, we are.
Excellent.
Great. Thank you for your patience, everyone.
Can everyone see the screen?
morning. Great. Can you see us? Are we?
Your mic's.
I thought the mic's on.
I can see you. I can see you. I can hear you. I can see you.
Okay. Good morning, everyone. Actually, you can turn to the first.
Good morning.
If you can go to the brain teaser. Oh, yes, I forgot. We're the teachers of Bermuda. I have Mr. Turner here, Mrs. Hartman here, and I'm Mrs. Richardson, Miss Richardson, and then we have Mr. Mahoney, who will probably walk in as we speak. We're going to begin by doing a brain teaser. I understand math is not everyone's favorite subject, so this is not where you have to add something. It's basically where you have to discover a pattern. So if you can just go to the PowerPoint slide. Are you guys looking at the slide or no? Because we can't see it.
Oh, you can see? Can you see St. Lucia?
Oh, now I see it, yes. Can everyone see the slide?
Western Jamaica, you're the only class. You need some response.
Oh, St. Lucia's
Tiana, are you hearing?
She's not in the room. It doesn't look like it.
She's not in the room?
No. Dr. Rainford?
Yes.
Okay, is everyone here or no? Oh, why didn't you give the answer? But you gave the answer.
I'm not seeing St. Lucia, but Western Jamaica is here and Mona is here.
Okay, because on our end we see St. Lucia, and St. Lucia is not in the room.
No, they're not in the room.
Okay.
But Mona is here. And WJC.
Okay, no problem. I can't see you, so I apologize if I'm not giving you eye contact. But what I'm going to ask everyone to, just in 2 minutes, just make a quick attempt at this brain teaser. The question is, what's the next number in the pattern? And I'm going to give you a hint. You don't have to add. You just have to think pattern-wise. Oh, and yes, what we thought was we'll FedEx a bag of gummy bears to the person who gets it right.
Boy.
If that entices you,
I think I'm going to
not
decide
good,
this
but
country.
it's resetting. Oh, sorry. That's Did I do it again?
No, that's good.
When you see calculate, why did you see that? Has anyone think they has the answer? Jomo, I want you to go last because I figure you're probably gonna get it first. Jomo, you there?
Yeah.
Did you get it already?
No.
No? Okay, great.
Alright, let's see.
I'll give you a few more seconds and then we can move forward and I'll give the answer.
Regina, start.
Does anyone else have the answer? Regina?
That's funny. I don't have a.
She's
You
your
don't have
friend,
a clue?
Regina.
Regina. Is it Regina or Regina?
Regina.
Did I get it right? Regina, thank you. I'm sorry about that. It is Regina? Okay, so do we all give up? Does anyone have the answer?
I surrender. Wait, 1, 1, 1, 3, 2, 1, 3, 2, 1, 1.
You Englishy, but you got it, you know.
They looked it up.
Oh, you looked it up. You're cheaters.
Snack time.
I don't know how to get to the answer though.
Well, let's share the answer with the rest of the class. I will not be FedExing the gummy bears because cheaters never win. The answer, if you go to the slide so we can do it quickly. Dr. Rainford, I can't see the slide.
The
If
slide.
you go to the slide, I would explain it to you. Basically, if you call out the numbers, you would actually get the pattern, which they did in Western Jamaica. I didn't say
Teacher.
Yes.
We're not hearing so clearly.
Are you hearing me better now?
Still low.
Still low.
It's still low?
Yes.
Yeah.
Can you hear me better?
We're listening, miss. We're listening.
Okay, I'm sorry. I'll try to protect my voice. Okay. So the pattern goes, if you look on the slide, if you call out the pattern, you actually can get the missing number. So the first one is 1. Then you see 1, 1. Then it's 2 1s. Then it's 1, 2, 1, 1. Then the next number is 1, 1, 1, 2, 2 1s. Then it's 3 1s, 2 1s, 1 1. Then you have 1 3, 1 1, 2 2s, and 2 1. And the answer would be then 1 1, 1 3, 2 1s, 3 2s, and 1 1. You got it?
I cannot see the slide.
Oh, we were looking for you. I apologize. Because I know you would have gotten it, Miss Chris, Miss Alfred. If you want to go back to the slide, because Miss Alfred can't see the slide. Dr. Rainford.
I'm on the slide. I'm not sure why they're not seeing the slide.
She can see. You can see it now, right?
Technician.
Yeah.
Can you look there?
We had just asked everyone to basically complete the pattern, and I did say because it's a mixture of us, it wasn't a calculation. It was actually you had to discover the pattern. And if you look in the screen, I'll give you the answer because we're gonna move forward.
I'm not sure why, but you were very low.
Oh. If I walk up to the screen, will it come? Okay, can you hear me better?
Yeah.
Better.
Better? Okay, I was telling, did everyone get the pattern? Oh, I'm sorry, it looked like, oh gosh, you see everything, that's too close. I'm sorry, we're just trying to adjust, play with our mic because it doesn't seem to cooperate. Okay, can everyone hear me better now?
Yeah.
Yes?
Yes, miss.
Go on the campus, can you hear me better?
Yes. Yes, miss.
Okay, I'm sorry about that. I had a microphone issues. So I was saying, did you understand the pattern? Did everyone get the pattern correct? Hello?
Well.
I can't hear anybody.
Guys, we're gonna ask you to just. I'm gonna ask that you just participate, please.
I'm sorry.
It's not that I'm really not hearing. It's not that I don't want to participate. It's me. It's really low.
It's
really low on work. Yeah, but you can't hear.
If we hang up and call you back, is that gonna be better?
We understand some parts of the pattern. At least we thought that we did at first.
We're gonna call you right back because something's wrong on our end. Is that okay?
Yes, that's fine.
Okay.
Okay.
Right.
But it's recording, so they have to call about the bridge.
You can tell them.
They gone.
17 now. So the first one is what? 1 plus 10, and then we'll give you 11, and then 11 plus 10 will give you 21. But how do we reach all the way to 1,000?
Okay, can you hear us better now?
Yes.
Perfect. Fantastic. I feel like we.
And one point that we have to make with the brain teaser, the number we said it out loud, we actually have to write the number of what we're saying.
Hello? So did anyone get the answer to the brain teaser? No? Okay, on a sheet of paper, have one handy or close by. What I'm going to ask you to do is, as I say the number, write it out, and then you should be able to get the answer, how we got to the pattern. Is that okay?
Okay.
Is everyone, did Donna hear me? Kiki and Dora?
Yes.
Okay, so first I'm going to say 1.
Alright.
Then write 1, 1.
1, 1.
Then write 2 ones. 2, 1.
2, 1.
Then it's 1, 2.
Hold on, 2, 1. 1, 2.
Then it's 1, 1.
1, 1.
And it's 1, 1.
1, 1.
Then it's 1, 2. And
1,
2,
2.
1.
So, Miss, it's 1, 1, 1.
It's 1, 1, 1, 2, and 2, 1.
Oh, 2, 1.
Then it's 3 ones. I don't know. Can you see? Can you see this far? No, you can't see that. Then it's 3 ones. So you can see that because Rosina's gonna point to you as I say it, because maybe that's more clear.
Okay.
So it's just gonna show you 1. Point to 1. They can. Very good. That's 1. Rosina, show me 1, 1. You just did it? Come on the next one. It's 1, 1. You got it? Oh. Then she's going to show you 2, 1.
2. See, this is 2, 1.
That's 1,
2, 1.
Yes.
Then it's 1, 2.
It's 1, 2.
Oh, I get it.
And then it's 1, 1.
And 1, 1. Oh.
Yes.
Then you have 1, 1.
And 1,
1, 2.
2.
1, 2.
Yes. And then
2
2
ones.
ones.
1.
Did you see 2 ones here?
Yeah, exactly.
Then you have 3 ones.
2 twos.
There you go. Someone's got the pattern. Was that you, Dr. Rainford?
Yes, I think so.
You got it. 2 ones. And then 1, 1.
Okay.
Then you have 1, 3. 1, 1. 2 ones. 2 twos, sorry. And then 2 ones.
Ones.
So the answer, if you can click it so I can show you the answer now. Click it, the PowerPoint once again. Oh, go back. He didn't give you the answer.
Let me give you the answer.
Oh,
not yet,
okay.
not yet, not yet, not yet.
You got it? Is that Kiva? Kezia?
Yes, I'm saying just give me a minute.
I give you a minute? Okay. A minute to minute. Okay.
Okay, I got it. It's 1 1 1 2 1 1 1. 2 1 1 1.
Okay, has it been a minute?
1 1. Yes, we're ready. We're ready.
You ready?
So,
Okay. Is someone say the answer?
1 3 1 1 2 2 2 1.
1 1. 1
Uh-huh.
3 2 1 3.
This one.
Let me start over. Let me start over.
Okay.
1 1 1 3.
Yes.
2 1.
Yes.
3 2 1 1.
Hey now. High five all the way from Bermuda. Oh, let me send the numbers by Korea.
That's the solution.
Yes.
Thank you, Kezia got it.
Okay. I got it.
Us lady.
But the lady in Jamaica campus, they had started it.
They got the solution.
They got the
They looked it up.
1 1 1 3 2 1 3 2 1 1. Okay.
Got it?
Yeah.
Okay. That's just something that we was to start you off this morning to get your brains ticking, because today we're gonna do, if you haven't been paying attention, sorry about that. We're gonna do order of operations with fractions. And this is somehow, it's gonna be something you should be familiar with, but to make sure that we're giving you something new, but we're gonna use some old mathematical concepts. So I'm gonna have Teacher Hartman do some revision with you with regards to fractions.
Okay, good morning. Our first one we're going to do, if we can turn to the first slide, or the next slide, is, can you do this calculation? What is 1/5 plus 3/5? I'm just going to give you about 3 seconds, 5 seconds to do it.
4/5.
Can everybody do that? Yes, no?
I really can't see anything, but then I can hear you, so I guess I'll follow your voice.
Okay. So can you do 1/5 plus 3/5?
Okay.
Actually, would it be a good time? Since you can't see us, Ms. Alfred, did you get the email?
4/5?
Everyone got the fraction? Did you get the fraction brought? The sheet?
I got mine. If I got my
look
one?
like this? Did you get this?
The fraction.
Yes, we did.
Okay, so if you take these out, we can use these. We're going to be using these as we go. So if you can use your fraction bar for talking. Okay, but this is just a quick review, so I was thinking you can do this in your head, so we had enough time, so we should come out with an answer of 4/5. If we go to the slide, and we can't see the slide.
We can
see. Rainford, we see St. Lucia. Let's see the slide.
And I can only see you, I can't see the slide.
Dr. Rainford, can you hear us?
Very well.
Okay, can you see it?
Okay, there we go.
There we go.
Thank you.
Very clearly.
Can you see that, Miss Alfred?
And
I can see Miss Alfred, yes, I can see.
but I can't pick out anything on it. But I'm going to follow with you.
So if you take out your the fraction bars, does everyone look at the fraction bar that's as 1/5?
Yes, miss.
You see it? So Ms. Carmen just asked us to add 1/5, which would be one of the bars, plus 3/5. So it's another 3. So that you start with 1, now you're gonna add 1, 2, 3. So you end up with how many?
4.
So if you didn't know how to do this in your head, you can do the fraction bars, and that will give you your answer. Always remember
2, 3,
that
4.
what is the principle? Does everybody remember the principle that you have to remember when you're adding fractions? Can anyone tell me?
Could you repeat, miss?
Can you tell me what the principle is when you're adding fractions and they have the same denominator?
You make the denominator stay the same, and you add the top ones.
That's correct. The top ones are called
really?
Very good. Look at Steve. She's an English major. Don't say you're excited. Very good. Now, what is the top number called? What's the mathematical term?
Oh, numerator.
Numerator. Very good. That's good. Okay, so let's go to the next slide. Which the next problem we have one third plus 2/5. 1/3 plus 2/5. Can we change to the slide? Western Jamaica, can you see the slide?
Sorry, which one is this?
Yes, there you go. So
that's the one?
Yeah.
1/3 plus 2/5. No, go back.
Go to another one. I think that was done in, that's your multiplication. He went ahead. It's this one.
Okay, so.
Yeah, 1/3 plus 2/5. Go back.
No, you go forward, sorry.
Go back.
It's that too.
Yeah.
Okay, so we'll leave that definition out. So just think of this in your mind or write it down on a piece of paper, 1/3 plus 2/5. So if you're using the bars, Ms. Richardson is going to show you how to do it on the bars. This is quickly done. You could do this in your brain, in your mind. So she's going to show you with some of the bars.
So everyone has a bar that reads 1/3. You should. Do you see a bar that? Can you see that? Right here.
We do. Yes.
You have your bar. So she just asked us, what was the equation again?
1/3.
You've got 1/3
plus 2/5.
Plus 2/5. Now, do you realize that?
No. What do you have to do? What did we say when we added the fraction? Denominator had to be what? If we're adding fractions.
The same.
The same, thank you. And so if they're, in this case, they're not the same, so what do you think we need to do? Shomo?
Yeah?
What do you think we need to do if we have two denominators that are not the same?
Get the same denominator.
We have to find the lowest common denominator, right?
Lowest common multiple.
So, in this case, can you tell me what that would be?
15 would be the lowest common multiple of 3 and 5.
15, correct. So then our equation was then, look, how do we change that to a 15? How do we change the 3 and the 5 to a 15?
What you have done is you have multiplied the 1/3 by 5 over 5, which is the 6, because 5 over 5 is the same as 1. So you keep the same number, and you get the 15, 5 over 15 is the same as 1/3. Basically you're doing equivalent fractions, basically. And you're converting it over 5.
And that's, so Jomo said that 1/3 is equal to 5 over 15, right?
Yeah.
So when you use if you have your fraction bars, that's 1 bar.
The one is the 15.
Which is 1/3 over.
We're gonna write the thirds on the 15, on the bar is the 15?
Yes, put it right on, put it right on there.
Okay.
There you go. And you should be able to count 5 out of those. So that's 1, 2, 3, 4, 5. Do you see that?
Okay, so those that are using the bars, you can either use your bars, or if you're a little bit more advanced, you can just multiply the two fractions by the denominator at the bottom that's coming between the two. Okay, so next, we're going to go next principle, which we're talking about doing the multiplication. So the next sum we're going to do is going to be 4 6s multiplied by 3/5. So 4 6 multiplied by 3/5.
And you should have a bar. You should have a bar that reads 1/6. If you look at that, and we're going to use the 1/5.
The question is 4 6 times 3/5, right?
That's correct. Chris Santiana, what is the rule when you're multiplying fractions? Can you tell me?
When we multiply fractions, we could just multiply right across.
You multiply right across when you multiply by fractions. So the first, what is another step that we can do if we have large numbers and we don't want to multiply the large number?
We can cancel out.
Cancel out or make it into a simpler form. Is that correct? Same thing? Okay, so the first step we should do anytime we have fractions, and no matter if they're large or small, they can be made smaller. We try to make the fractions smaller so that we can multiply by smaller numbers, right? So our first step will be to simplify the fractions and then multiply the, what did you say? Multiply across. What do you multiply across?
What's that?
What do you multiply across?
What do we multiply across?
Yes.
So the 4 times the 3 and the 6 times the 5?
Yes. What is the 4 and the 3?
4. I'm not getting
What is the name given to the 4 and the 3?
The numerator.
What's she saying?
Numerator.
Yes, you multiply the numerators and then we multiply the
denominators.
Denominators to get our answer. Exactly. So that's what we did. Now, Christy, you want to show them on the bars? Okay. All right. So
well, we can show you.
You want to do division first, and then okay.
Well, because what you're going to do is, and the concept that I'm going to show you on the bars, that is something that you can apply in the sense of when you multiply fractions, you're actually going to make the quantity go down, if you understand what I'm saying, because it's a number of. So we have, if you look at it, you have 4 6, which is 1 2 3 4. Do you see that quantity? If you can pull it out, right? And you have 3/5. 1 2 3. If you have your fraction bars that read that. So what they've converted into 1/5. So your answer, if you multiply across in the bottom, you would come up with What's the answer that you will come up with? Someone can say?
12 over 30. 12 over 30.
12 over 30.
And then
if you make it into simpler forms, because remember we don't need numbers in this large quantities. If it could be divisible by other numbers, so how do we make it smaller or simplify? So we take what?
Can the teacher assistant, can she come and go through that yard and demonstrate what to do?
Say it again, Crescentiana.
I would like the teacher assistant with the street.
2, 3.
Yeah, so how did you finally use this to get your answer?
Well, what I was saying is you have your 4 6. You see that?
Yeah.
And then you have your 1/5. But what I'm going to show is that the number actually goes down when you multiply fractions. The actual value, the quantity will go down. So she started off, I think when you multiply it across, and I don't have a 30. Sorry, I do apologize. She multiplied across, so she did 4 times 3. And I think you got 12 over 30.
30, yeah.
Right? So when you have 12 over 30, that I can't show because I didn't have the 30th. So when you first reduce it down, you get
6 over 15.
You get 6 over 15.
6 over 15.
So if I'm going to show you 1, 2, 3, 4, 5, 6. So you have 6 over 15. Can that number be reduced any further?
Yes.
Yeah.
You can 3 can go into the totem. So it's 2, 3, 2/3.
So 2.
2 what?
3 goes into 6.
How many times?
Yes. I got it.
That's okay, it's twice. And then into 15 goes how many times? 3 goes into 15 how many times? 5.
So you got 2/3. You got it? So it's 2/3. 2/5. I'm sorry. No wonder this guy.
It's 2/5.
Oh
no.
You said 2/3 to 2/5 because I'm going to show you how you can tell if your answer's wrong. I've got 2/3 here, and we said how many 15ths it went into?
We said it was 6/15.
6. So does these two equal up? Do they line up together? You have 1, 2, 3, 4, 5, 6, right? And you tell me that 2/3 equal to 6/15. Is that true? When you look at your thing? Sorry, let me bend it.
You look at your bars.
When you look at your bars.
So that's how you know your answer.
That would be incorrect. You see that?
No.
Can you see that?
So that's how you know 2/3 is not correct. Because it's not equal to the 6/15.
Miss Alfred, you see that?
Yes, I can see it.
Okay. But what does equal to this would be, what was the correct answer? 2/5? Is 2/5 equal?
Yeah.
You got it? So now you know your answer would be correct. So you can always use your fraction bars also as a method of double checking to see whether or not you worked it out correctly.
Okay.
Okay?
So addition, subtraction, and multiplication. When we do division of fractions, what is something that you have to do? Is there anything you can remember that has to take place before when we're dividing fractions? I'm going to give you a fraction. 2/3 divided by 5/6. They can't because it's not there. Okay. Okay, so what's can we turn to the next slide where it says dividing fractions?
We're there.
Okay. So, anyone to give us what is required when you're dividing fractions? Regina?
Regina?
I don't want to.
Adrian, welcome.
You invert the fractions you're dividing by.
Can you help your colleagues?
In this case, 5/6.
So inverting.
What was the cross operation
So
that you did?
you should change. You should invert the number.
So what would happen?
Are you saying
It will
you
be
should
6
turn
over
the
5?
numbers around?
Yes, that's what
My heart.
What they asked you.
Repeat.
Okay. So are you saying we should turn the numbers around?
So you turn the numbers around. Yes, for invert. So it's
So we shall
3
invert
over
the
2. Does it stay like that?
3 over 2. Is that what you should do, Adrian, or should we? Did you say 5/6? We should invert. Which one we should
It
invert?
should be 6/5.
6/5, and then what do we do with the operation? Because
It changes to multiplication.
it changes to multiplication.
Change on
So what
sign.
do we do? And what happens to the first fraction?
It remains the same.
It remains the same. That's correct. So now our problems now state what? What is our problem going to look like now, Regina? What's the problem looking like now that we've inverted the fractions?
2/3 times 6/5.
That's
Yes.
correct. That's correct. So, Keezy, do you know what the next step will be after we've inverted the 5/6? And we've changed the operation to multiplication?
You can multiply numerator by numerator and denominator by denominator. Or
That is correct. Or
if there's a numerator that can reduce a denominator, you can do that as well.
that is correct. That is correct. And so once we simplify and once we've inverted and changed the operations, we then can do the same steps that we do for multiplication that we do for division. Okay? So now that we've understood it and we've got our basic understanding of how fractions and how they operate when they do the operations of addition, subtraction, multiplication, and division, we're now going on to teach you a new way of dealing with equations when they're doing a cross using the operations and what operations should go in what order.
Okay.
And that's going to be done by Ms. Richardson. Or make-believe Mr. Maroney.
I don't have a deep voice, so I'm going to try my best. If you want to go to the next slide, please. We are going to look at order of operations. And before we can go into what the whole concept of order of operations, I'm going to ask anybody, does anyone have any clue what the term order of operations may indicate? And not just in the math jargon, what do you think, like what's the order of operations? Example. Anyone has any examples? I'm going to say one and then maybe you can repeat something similar. When we read, we usually read right to left, no? Or do we read left to right?
You read left to right?
Or do you read right to left? How do you read?
Left
to right? There you go. Is that an order of operation? Because if you read it back, if you read it right to left, are you going to be able to read what's in the book?
Answer?
Anybody? Yes? No? What would the result be? Huh? Shall I prove the point?
Answer them.
Yes, Miss Alfred?
I said we don't just operate from left to right.
Because sometimes you go, right, that's true, you go up and down, that's true. I guess, can you give me an example of an order of operations that you need to do first? Like when you get in your car, in order for your car to start, you need to have the key in the ignition, no? Is that an order of operation? Yes? No? Okay, can you give me an example? Can someone give me one example of the order of operation?
What did we just do? You invert. That's when you're what? When you're doing the division. What do you do?
There you go.
You invert the second one.
The first one.
Yes.
Change the sign to multiplication.
Change the sign to multiplication. That's what you do first?
There you go. Yes, you're absolutely correct. Don't just, you got it. And I was looking for a real life representation. Like in order to turn on the lights, the order of operation would be you have to turn on a switch. No?
Yeah.
Okay. So just like in the world we have common order of operations, we actually have order of operations that we have to apply in the mathematical world. And that's what we're going to look at, the mathematical concepts of order of operation. So in order to solve problems, we have to use an order that has been established, and you work from the left to the right. Okay? If you could flip to the next slide, please. And it's actually, because it's such a, it's so many mathematical concepts that you have to think about with math. Like you have to think about addition, you have to think about division, you have to think about subtraction. You have to think about so many things. We actually came up with an acronym, BEDMAS, which you could kind of remember the order of operations. So if you can look on the slide, can everyone see the slide that we have called BEDMAS?
Yes.
Can you read it? So the first operations that we have is called brackets. Sometimes it's called parentheses. So whenever you see the brackets, you know that comes first. The second will be E, which is exponents. Are we all familiar with these concepts?
Anyone not?
Anyone not familiar with any of
What are exponents?
You're not familiar with an exponent? I know you are.
Yes, I asked the meaning.
Yes. Oh, the meaning of an exponent. An exponent is when you take the number to a power. So it could be to the second power, to the third power. That's when you see that small number. Do you remember that in math?
2 to the 0, and then more than
2 to the second power. We had just explored that in the binary numbers, remember?
2 to the 0.
Okay.
We had the binary block, then we did 2 to the 0. Did you remember all those? That will be a representation of an exponent.
The exponent in the binary
thank
you.
0.
Okay. So the next one, you have D for division. If you can go to the slide again, you have D for division. So we started, B is always brackets are first, then it's E, exponents, it's D for division, you have M for multiplications, then you have A for addition, and last but not least is subtraction. Okay? Did everyone follow along? Can we say that together, please? BEDMAS. What does BEDMAS stand for?
Brackets, exponents, division, multiplication.
So one is for addition and subtraction.
I think that's just a repetition. But the S is just for subtraction or both of them.
It was just subtraction. I'm sorry about that. That is an arrow on the card. Teachers make mistakes. Horrible. Okay, so now that we've understood the concept of BEDMAS, or you understand the definition of order of operation in terms of the math-related concepts, let's move to the next slide. And we're going to go through what brackets look like, which is the first operation, so you can be familiar with when you see it in the an equation. If we can move to the next slide. So can someone tell me what numbers are in the brackets for this equation?
2. Do you say plus or 4? 2 and 4.
Yes, that's a plus. 2 plus what?
4.
4, absolutely correct. Does everyone see that? Jomo, do you see that? And Kezia?
Yes.
Okay. So you see what's in the brackets is 2 plus 4. Now, the second step, which we talked about, you can click the next slide, it says exponent. Can someone in Mona tell me what is the exponent represented in that equation?
5 squared.
That's absolutely correct. Thank you, Jomo. Moving on to the next slide, where we think about division and multiplication. And this is something that we're all quite familiar with. Our funny way of doing the division would be the asterisk. So it's 5 divided by 6.
No, 5.
I'm sorry, that's multiplication. I'm sorry, the division is down at the bottom. Can you tell me what numbers are multiplied in this equation? I kind of said it for you. It's that funny asterisk is our multiplication sign here. Mrs. Alfred, can you see the slide?
Not at all.
Okay. Well, can someone tell Miss Alfred what's multiplied in that equation?
5 and 6.
5 and 6. Absolutely, you're correct. And moving on to division. What numbers are being divided in this equation? Jomo, Kezia, Dr. Rainford?
Yes, they can see.
Oh, tell me what it is. I was asking what two numbers are being divided in that equation.
36 is being divided by 6.
Absolutely correct. Actually, look who's here. Mr. He is here. I'm going to pass his slides to him, and I'm going to step across. Thank you for listening.
Okay.
She just did this.
So what's the steps? You go to the examples.
The phone?
Yeah, one.
The addition and subtraction is the next slide. If you want to move to that one, I actually finished this one off, and then you can go to the examples. How's that? Fair trade? Cool. If you can, the last two, does everyone remember what the last two of the acronym was? Can anyone tell me what the last two mathematical concepts were?
Addition and subtraction.
Exactly. You know what? You should choose math as major because you have all the correct answers. Do you know that?
Wow.
She is outshining my math majors. Gee. Yes. So what two numbers? I'll give it to Ms. Dr. Rainford, since I know you're so smart. I know science is your thing. But what two numbers are being added in this equation?
5 and 4.
Absolutely correct. And Kezia, what numbers are being subtracted in the last equation?
9 and 6.
Absolutely. So can we just recall? Does anyone remember offhand what we just talked? What does BEDMAS stand for? What's the B?
Bracket.
Absolutely. What's the E for?
Exponent.
What's the next one? BEDMAS.
Better remember the D. Division.
Oh, huh. Division.
Multiplication.
What's the M stand for? Multiplication. What's the A?
Addition.
And the
and
S?
subtraction.
Absolutely.
Subtraction.
Very good. Ms. Alfred, did you get that? I know you can hear us.
Yeah.
It's good. Are you okay with just hearing us? Are we saying it clearly for you?
Yeah, I'm gonna listen.
Okay, I'm sorry. Okay, now you're gonna hear Mahoney.
Okay, now that we learned what bad math is, let's go through how to solve a problem. So using bad math and fractions. Using bad math, do the operations of fractions.
Can we see the board, the screen, please?
Skip the next 18. Slide 18.
Can you get to slide 18?
Not sure what's happening with the screen.
Yes, I think that's it.
No.
That's
Next one more.
Next, one more.
Just for time's sake.
What do you want them to do?
Go forward.
Forward.
Next slide.
Not sure what forward
To the
means.
next
Oh,
slide.
but next slide.
Next slide.
Keep going. Sorry, keep going. Next
This
one.
one? The other one?
No, yeah, that one right
No,
there.
next
Stop.
one.
No, next one.
Slide 18.
Oh, I'm sorry, I don't have the numbers.
Okay,
All right,
here
yeah,
we go.
that's it.
So the first, okay.
So, and when we did bad math, our first step is to look at the brackets. So, what would be the brackets in this problem?
2 plus 4.
Exactly. So that would be your first step.
So next
Uh,
line.
yeah. So now we have 6. So then our next step would be what?
Exponent. 2 to the 4th power. 16.
Yes.
Yeah. As you see, is in decimal form. 1 to the 6. 1 over 16 is in decimal form now. Then we would go with. Then what would we do after that?
2/3 times 6. 4.
Yeah. Very good, Jimbo. Yeah. And then what would we do after that?
Add and then subtract.
Correct.
This is for Chris Santiano.
All right. Then
Can you see that?
Yeah.
Okay.
Then we're gonna go on to the next problem.
All right, continuation from this problem. As you know, we also did fractions. And Adrian, in lesson counts, what would be first in this situation?
Adrian!
Yes, repeat please.
What would you do first in this problem?
First I would find the exponential there, the exponent, 2/3,
Can you tell me
and
your
then
first
I
step
would
now?
do the bracket
Okay, what's the bracket?
to arrive at my answer.
So the first, in the bracket, what would it be?
15.
All right, 15, thank you, Chris Santiana. All right, Chris, what would you do next?
Find a 5 over 8. Find the exponent.
All right, thank you, Jimbo. And, okay,
It's
what would be next, Jimbo?
when I follow the 15 about it, have a 5 over 8, and then add the 5 over 8 with 5, and you go to change the 5 to 40 over 8 plus 5, would I give 45 over 8.
They're not Jamaican.
Yeah, you're right.
But add the 5 with 5 over 8.
Yep.
And then I'd subtract the one last.
Yes, correct. He did the fractions first. You know what I'm saying? So.
It should not have been 15, it should have been 518, so it is 0.625.
Yeah, correct. Key student, Jeremiah, key student.
Key.
Yeah, he did. Jeremiah, we might have to send you a package of gummy bears. All right, the next slide, please. All right, we went through definition of bed mass and fractions. The examples we gave the students, and we also gave non-examples. Do you guys have any other operations would you prefer to do? Because I know there's other areas of what they call acronyms. Do you guys have any acronyms that you use or you know of in your math terminology?
Why not? With a high level.
What's the acronym you know of, Jomo?
You have acronym in calculus. You have a thing called integration by parts. And sometimes you have students that use this thing called isolate, but it's a high level type of something. But basically it's like you have an inverse, then you have a logarithm. Isolate would be I stands for inverse, L stands for logarithm, A stands for algebra, T is a trigonometric identities, and E would be exponential functions. That's the only one I can remember off my class. Oh yes.
Chris Santiana, any algorithms you know or that you use in math?
Can't recall right now.
Yeah, acronyms.
Yes.
Yeah.
In trigonometry. Or sometimes some people say all silly tomcat.
What was that, Jimbo?
In trigonometry, and you have a thing called CAS, or some students will say all silly.
Cast at fees, cosine, all trig ratios, tangent, and sine.
Okay.
So you have the SOHCAHTOA form, which we all know.
Yeah. SOHCAHTOA.
We have we have a worksheet that was sent, and we would like for you guys to actually do the worksheet and send it back to us, if possible. And practice. Using your badness and understand, well, you all understand fractions. So please, that'll be your homework.
Okay.
Thank you, Bermuda.
Thank you.
All right, have a. Maybe a bit hungry. Are you hungry in Bermuda?
Yes. No, I'm starving. I need this food.
What's that around us?
I'm starving. I need some food.
I thought so. It is 2:30. 2:15. All right. Okay. So let's do a half an hour. Is that enough?
Sure.
Okay. Let's do 40 minutes, and then we will come back to do the other two lessons.
Okay.
Western Jamaica, did you send me the PowerPoint? You did you not? Yes, I think I have it.
She is one. Yeah.
No, the word, that's something, that's some how we consider, I don't think, the different knowledge word.
I can't.
Show me let her know that people don't speak German. They have to really make an effort to communicate in languages that everybody can understand. You can't just be talking as if you don't know what you're talking about, people don't understand.
Am I left side?
No, I don't want to understand. We communicate in English, let us, I'm sure you know that.
No. She gave you what she
Oh,
thought
no, just
of your lesson. So basically, you have to write it up. Like, the things that you did bad and the things that you did good, you write it up.
Yeah.
And then you send it to her. This is of the whole course. What you thought of it, you think she was a good teacher, and something that you could do better. What improvements are you gonna take? What are you gonna take from this course and move on to the next course?
I already have being culinary and
You guys get some lunch?
yeah, I'm gonna get something. Okay. I need some food. I had cereal. I wanted to get a bad torch, but I couldn't find my Jamaican book this morning.
You want to go where?
I wanted to make some banana porridge.
Porridge?
Repeat again.
Western Jamaica, are you hearing me?
Yes, miss.
Do you have a PowerPoint to your lesson?
No, we don't.
Okay, fine. Great. Then you don't have one either. You go away.
Hi, Miss. Are you there?
I'm here, Adrian.
Yes, Miss. There is actually have a staff meeting today, and I have a departmental presentation in a bit. So, is there anything we can do to facilitate that?
If you didn't say that earlier, I would have taken it. I wouldn't have sent it a break.
Okay. All right, I will just try and remain for the rest of the presentation.
Yeah, but they have half an hour.
Okay. All right.
WJC? Can you turn on the mic so they can hear, please? Yes, miss? Okay. We're hearing you all along. Are you behaving like you didn't hear me? First up, see Dario's face.
Really?
Yes.
Well, I know it's a pleasure.
What did you say? It's a pleasure. All right, come now. We're ready for you, WJC. Do your sound checks. See if they can hear you.
Imagine you have to stay cool with all this stuff on the if they don't talk that language, you know what I mean? They're not going to talk this language. Just like when I do accounting, I tell these students, they don't, this is language of accounting. This is not language of accounting. Like you're going to teach me something. This is something you'll hear of in the workforce. But this story is
This is my Gmail.
Marcia.
That would have been state. Like the other day. Who's distracted? Yeah, sometimes you're distracted.
WJC, we're ready waiting on you.
Okay. All right, welcome back from lunch. I hope you had a very wonderful and filling lunch. We are going to be doing integrated studies today. Can you all hear?
Yes.
Yes.
I'm sorry, we have some mowing going on outside.
I don't think.
We're not hearing the mowing though. We heard the trucks and the cars.
Please, we are cutting the lawn outside. I'm gonna go and ask if they could give us half an hour.
Please, yes, tell them to cut somewhere else.
It's not lawn, you know. They're actually digging out a hole over there. Drilling something up there. All right. Drilling some. So in the meantime, we'll just take attendance and see who is here. Bermuda, I can see you. St. Lucia. Hi. St. Lucia. Hi. And I know Mona is here. Well, it seems as though they are a little,
Let's continue until Adrian gets back.
All right. Can you all hear?
Yes.
Want to make sure that we are clear?
Yep.
Okay. All right, so today we are going to be doing integrated studies. We are going to be looking primarily at geometry and dictionary skills. So it's an integration of math and English. I know that some of us, we might be having a little problem re our dictionary skills. And so today we're going to be taking time out and we're going to see how well we can address the issues that we are having. Now, what are our objectives for the day? The first thing, we we are going to be able to do is identify or say what is geometry. We are also going to be able to identify shapes after we look at pictures. We are going to be able to spell the names of the shapes, especially the unfamiliar ones. We are going to be looking at meanings for those shapes. Some of the meanings we'll be able to construct after we look at the shapes themselves. We will be doing a little group work, so get ready. We are going to be doing cooperative learning activities. We are going to be able to alphabetically arrange some words that you're going to be given. And finally, we are going to be making a dictionary for our shapes. Are all the objectives clear?
Yes, ma'am.
Yes.
We're following? Very good. Now, it might seem like a long list of objectives, but they are pretty simple. And so, as we go through them, I'm going to ensure that we bring them back and make the necessary connections so you are able to follow. Now, before we do anything, we're going to be doing our introductory activity. I want you to take a while. We're going to take 2 minutes. We're going to take 2 minutes. It's not going to take so long, but I mean, we will see how fast we can get this over with. Now, our first activity, or introductory activity, arrange us in the right order. So I have 5 words on the board. For the persons who are in the back and they can't see so well, I'm going to call the words for you. So you can just take out a sheet of paper, take out your books, and write these words down. Is the instruction clear? So you're going to arrange the words that I'm going to call in their right order, in the order in which you would see them or find them in the dictionary. Is everything clear?
Yeah.
All right, very good. The word I have first is height, width, length, circumference, and measurement. So it is height, width, length, circumference, and measurement. So I'm going to give you your few minutes, your 2 minutes for you to look at the words, and then we're going to arrange them together. We're going to use numbers so as to say in what order they are going to fall. So number 1 for what comes first, number 2, 3, 4, 5. Is everything clear?
Yes. Yeah.
All right. So I'm giving you your minute.
Done.
Oh, you're done. That's excellent. Yes, we are very brilliant. All right. So what's number 1?
Circumference.
Circumference. Very, very good. Number 2?
Height.
Height. Number 3?
Length.
Length. Number 4?
Measurement.
Measurement. And the final word is?
Width.
Very good. Excellent. Now, based on the activity, I hope that you understand the meaning of what we say when we ask you to alphabetically arrange things. So what does it mean now? What does alphabetically arrange mean?
Put them in the order of which letter comes first.
One at a time. One at a time. Let's see your hands. So Bermuda, you are going first.
Put them in order of which letter is first, or what letter comes first in the dictionary.
Excellent. Very good. Very good try, Orantos. All right. Now, to introduce the term geometry, we're going to be looking at the word itself. The word itself. Can anybody tell me a word that comes to mind when they hear geometry? Can you tell me of something that stands out to you when you see the term? So it is Geometry.
All right, anybody? What comes to mind when you hear or see the term geometry?
Measurement.
We didn't hear. Can you speak up, please?
Sorry, measurement. Shapes. Or shapes?
Measurement, shapes. Somebody say shapes.
Somebody said shapes? Did somebody say shapes?
Yes.
All right, dance.
So shapes. Anything else?
Measurement, lines.
Lines, very good.
Angles.
Good job.
Measurement.
Measuring. All right.
Good.
Great.
All right, so is that all? All right. I'm also hoping that you're seeing how the words that were on the board also come in with the word geometry. So it's good how you are using the words that were on the board as well.
All right. All right. What we're going to do now is we are going to try to form a definition for the word geometry based on some of these things that came to your mind just now. So you're going to take 1 minute or 2 minutes and you're going to write, or you're going to attempt to write a definition for the term geometry. So based on what we just said, try to form a definition for the word. Is that clear? Okay.
Shapes, lines, is the use of
They can't see nothing.
data.
Yeah.
You missed it. Never got it.
They couldn't get them.
I went online and I was like, number is. I said, well, what's the tag?
All right, did anybody come up with a definition for the term?
So the words that you had were shapes, you gave width, they gave measurement, angles, All right, so we're going to take somebody. Saint Lucia, Sienna.
I have the geometry is the study of shapes, lines, based on their construction and measurement.
Okay, good. Rick, what do you have for your definition?
It is a method of mathematics that uses shapes, lines, and measurement of angles.
Okay. Crystal, let's hear what you have.
Honestly, I don't have anything. I'm sorry. But I can guess.
All right, so we're going to use
You
the
see,
word.
Crystal, that's why we don't allow eating in class. You had a very long lunch break, okay? Okay.
I didn't want to talk with my mouth full. She insists.
Crystal.
Rantos, you have a definition for us?
Sure, how deep do you want the definition to go? All right, geo is an Earth word, and it means geometry is a branch of mathematics concerning the concerns of questions of shape, size, related positions of figures, and the property of space.
Okay, excellent. Okay, let's go over to Kingston.
Jomo, any answer for what is geometry?
Geometry is concerned with shape, size, measurements, and angles of an object.
Alright, so based on what you are, alright, what you said, what everybody said was correct. But since you guys are just in the 7th grade, we're going to try our best to give you a more simple definition. So the definition we're going to work with is alright, so we're going to work with the definition that geometry is the study of shapes and their measurement. As you progress in other grades, you will realize that the definition really won't change, but things will be added to it. But for the grade 7 level, we're just going to stick to the study of shapes and their measurements. Are we all clear? Do we have any questions so far? Oh, we are all clear. Okay. Brainstorm in the name of the shapes. Alright, the next thing we're going to do, you're going to tell me the names of the different shapes that you know. So since geometry is all about shapes, you're going to tell me the names of the different shapes that you know. Anybody can know.
A trapezoid.
Square.
What?
We're gonna have to consider the circle.
A rectangle.
Square.
Square.
Rectangle, square.
Anything else?
Hexagon.
What was that?
A decagon.
Any other shape?
Septagon.
Triangle.
A cube.
Yeah.
Where was the triangle?
Did somebody just say?
A cube. I made it like 5. Nobody put mine.
Alright, 1, 2, 3, 4, 5.
Students, can you think of any more three-dimensional shapes?
Sphere.
For example, the cube here.
Cylinder.
Very good.
Good.
A rectangular prism.
It's a poke cuboid.
Cone, ice cream cone.
We didn't get that.
A cone.
A cone.
A cone.
Alright.
Yeah, I'm a shape of content.
Yeah, I think you would.
They're really separate and not shapes.
Yeah.
Okay, so the shapes we have so far, the trapezoid, the circle, rectangle, square, the octagon, the triangle, the cube, the cylinder, the cone. Anything else?
What shape would you classify a football as?
Sphere.
Oh,
Sphere.
Yeah.
Thank you very much.
How about a diamond?
Yeah.
I don't know.
I don't know.
Say you take the big.
Alright, so
Let's,
let's see.
uh,
Alright, so
let-
Alright, so we have gone through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have gone through 10 shapes. But remember that this lesson is an integrated lesson, right? So this is the mathematical aspect. We are going to trip a little bit over to the English aspect. Can anybody pronounce the first word on the board for me? Anybody?
Trapezoid.
Trapezoid.
Go again?
Trapezoid.
How many syllables does it have?
Trapezoid. Three.
Go again, how many syllables?
Three.
Alright, good. Can anybody pronounce the... Alright, could somebody spell a rectangle for me without even looking on the board?
Spell.
The what?
Could we spell the word rectangle?
Rectangle.
Rectangle.
Rectangle?
Yeah, right.
Come on, guys, spell.
R-E-P-A-N-G-L-E.
Good job. Very good. What's it spell like?
Alright, so the next thing you're going to do for me, you're going to move into your groups, basically, because the main activity we want you to do is, we want you to compose a dictionary that is based on geometry. So you're going to move into your groups. What you're going to do is, or before you move into your groups, take a minute and do you have a handout? Did we see the handout? Did you guys get the handout?
Oh, the shapes.
The one with the shapes and the words.
No, don't want that.
Well, they send it out. You know,
Oh,
you
Gina.
share it in somebody. Oh, with Gina. Yeah.
Yeah,
I emailed it. Everybody should have it. The one with the shapes and the words at the bottom.
Yes, we have it. I have it.
Alright. So you're basically going to use this handout to do your group activity, right? What you're going to do is you're going to compose a dictionary based on the shapes. So the words are there in alphabetical order. So what you're going to do is you're going to use your dictionary to find the meaning of each shape, and underneath that you are going to draw each shape. So look at the handout, see how each shape is drawn. So basically your dictionary is going to consist of the meaning plus the drawing. Is that understood? Is that clear enough? Alright, so that's the activity you're going to do. And that should take you no more than 10 minutes.
The meaning and the drawing?
The meaning and the drawing. So the first one is a circle. You're going to use your dictionary and you're going to tell me the meaning of circle. So you're going to write it, and underneath the definition you're going to do the drawing of the circle.
Okay.
Okay. 5 minutes?
Start right there. No, person. Did you say the beginning?
He's your friend.
There you go.
And
Look up.
My email's not working somehow. I'm sorry. And I just wanted to tell her.
You have to go to Court Street.
Seriously?
I don't understand why it's been on one location. If you're a business partner, you can't go here, you have to go upstairs.
Nice.
Are you reading out loud?
No.
Yeah, what's he supposed to have?
Well, I can't do
Round
it.
shape, a line that is characterized as M, Q, and every
I went to
line.
Yeah. I just put it in class.
Cylinder. Oh, I didn't even have the email to see what word I was on. Circle. And you got draw it?
Yeah.
Circle. Page.
So perfectly aligned shape. See where the V is right. A perfectly aligned shape.
A perfectly top shape with just enough a little
Cube.
What happens to cylinder?
Is that the cube?
Oh, so it is.
Cube. What is cube connecting?
What's the cube? So you know what's the
Maybe the
cube?
shape of six surface there.
Same
Six
cube.
surface. Same shape is 6 equals surface equals.
We're inside. I started with 6.
Have we done number 1, which is finding the definition for circle? Have we done it yet?
Yes.
Very good. So I heard Crescentiana, can you just please read the definition that you found in the dictionary for circle?
A plane shape which is enclosed by a perfectly round line.
A plane shape
which is
in an
enclosed by a perfectly round line.
Yes, a perfectly round line. All right, very, very good. Does everybody have that same definition? Or
Yes.
something that is similar to that?
Yes.
So we made it up. Shape of a toilet inside the toilet with meats.
16 gives you.
Oval is what's the next one? Octagon. That's the octagon. Yeah. 8-sided figure.
So that's one definition. So hopefully we are done with our very first drawing and definition. We can go to the second.
Crystal, you said that a three-dimensional geometric shape.
Shape. What is the second shape on the handout?
Cylinder.
Cube. The cylinder.
Cube.
Oh, sorry, cube.
Which one? Oh, the cube.
The cylinder.
Geometric shape.
And the telephone. I can't write that. The shade, the inside. Yeah.
All right, so definition for cube. Let's read that definition together. Go together. I just want to know that you're on the right track, so.
And then instead of swing size tape or five.
It's 911. Oh. Like what?
People remember stuff if you relate it to fingerprints. Think about it. Every time you press that photo, and then what they hit.
My structures that they use. So what's a keyboard?
A solid with 60 square size.
You don't mind Hannibal?
A cube is a solid with 6 equal square sides.
And say, oh, these are good. If I thought you wanted. How do you have to do that?
Yeah, these guys can read.
I suppose.
Okay. What is the next shape that you have?
Cylinder.
Cylinder.
Okay. Can someone read your definition for a cylinder, please?
A three-dimensional geometric shape.
A three-dimensional geometric shape. Do you have any other definition? I'm not completely satisfied with that definition.
That has a cross, it's cross-sectional.
Right. It has a circle as its cross-section. So not only is the circle three-dimensional, it has a circle as its cross-section or its base. So Rantos, you need to make a note of that, right?
Yes.
Okay, next shape. Okay, the octagon. What's the definition of an octagon?
An eight-sided plain shape enclosed by straight sides.
Great, right?
Say that
An
once
octagon has 8 sides.
As is suggested by the prefix octo, as in an octopus has 8 legs. Yes. So the prefix octo.
Yeah.
Okay, next shape.
Yeah.
Definition for the next shape, please.
Oh.
What do you have for oval?
Something that has the shape of an S.
Really?
A five-sided plain shape enclosed by straight sides.
A 5-sided
Plain shape enclosed by straight sides.
Okay, so that's the definition of a pentagon. Good.
Yeah.
Oh. Oh, that's cool. That's cool.
Okay, next shape.
Rectangle.
Rectangle.
Yes, let me have the definition for a rectangle.
The opposite sides are equal. So plain figure
We're opposite sides.
A plane figure with the opposite sides equal.
Yes, sir.
I'm not aware, right hand. Not to form right angles also.
Okay, I would have rather if you made mention to the fact that it is also a quadrilateral, right? Having 4 sides, okay?
Yes.
Okay, on to the next shape.
This one says the same.
Okay, what's the definition of the next shape?
It says, is it perfectly wrong? Is a perfectly round geometric circular object in a three-dimensional space that is representative of the shape of a complete round hole. You got that, Adrian?
Could you read that definition for me again, Orantos?
It's a perfectly round geometrical and circular object in three-dimensional space that resembles the shape of a completely round ball.
Okay, that's correct.
Can somebody give me another object that would be shaped like a sphere? Oh, yes, very good. Alright, so I am going to take my little time and I'm going to collect the dictionaries. So the persons who didn't draw there so well, I hope that you get a little time to just complete. I'll give you a little time to complete that. So let's go over our objectives again. So by now we should be able to state what geometry entails. What is it again? What is geometry? Let's recap.
Shape.
It has to do with shapes, the study of shapes and their measurements. And we went through that. We know, for example, when you talk about the rectangle, the two opposite sides, they are going to be the same measurement. Alright, so we went through and we identified shapes. Any three? Can we remind ourselves of 3 shapes? Quickly? Good? Yes? Very good. So we can spell cylinder. Can we? Cylinder? Very quickly. C-L-I-N-D-R. Cylinder.
C-Y-L-I-N-D-E-R.
Very, very, very good dictionary spelling. Very good. All right. We found the meaning of shapes, and I'm almost certain by now that when you look at the shapes, you'll be able to tell their definitions. You'll be able to recall their definitions. So when you see a rectangle, you'll be able to tell me what it means, what is needed for it to be a rectangle. When you hear a circle, you should be able to, or when you see a circle, you should be able to say why something is a circle or why it is circular. When you hear octagon, as I said before, the prefix octo means it's going to have 8 sides somewhere there. and then we worked in our groups, and we were able to alphabetically arrange the shapes that we found, and now we have our dictionaries that I'll collect in about 5 minutes. So we've met all the objectives for the day. Right? Do you have any questions about any of the shapes? Do you have anything to add? No?
No questions.
Then that means that class is done for the day. I hope to see you next time. Have a great day, everybody.
Thank you.
Oh, before you leave, please please write down your assignment. Before you read, please write down your assignment. It's due next class. Alright, so next class I'm going to give a little pop quiz. So you should be able to spell at least 12 of the major geometrical shapes. The ones that we did in class. We did 10 on the board, but you can add parallelogram to it. And yes, and the handout that you have, all the shapes are mentioned on it. So your first assignment, practice to spell all 12 major geometrical shapes. And secondly, I want you to draw diagrams. We already did. I want you to use something to create at least 5 of the shapes. Let me tell you the shapes that we're going to be making. You're going to be making the triangle. So put a tick beside the triangle. So you're going to be using cartridge paper or any other material that you have to make these shapes. The triangle, the rectangle, square, trapezoid, and the pentagon. You're going to make 5 shapes. After you have made those shapes, I want you to state their measurement and the length of each side. The measurement and length. The measurement of each side. Is your homework clear?
Yes.
Alright, very good. So have a great day, everybody. That's it for class. Have a great day.
Thanks, Western Jamaica. Alright, Adrian, I hope that you're not too late for your meeting and your appointment. Can you all hear me?
Yes. Yep.
Oh, excellent. But we only have one more lesson, and I think we can manage that in the time we have. So we're going to have Mona mathematics. I have got critiques from everyone. Have I got Bermuda? Did I get yours?
She said it.
We're going to send it this afternoon.
Huh?
We're going to send it this evening.
Please, I've been marking them, and I want to give you some feedback so you can get a sense of what you've done. So I want you to give me some feedback on today's class and on your critiques before you attempt the evaluation. Okay?
Okay.
So let me have it so I can send you some feedback so you can have a sense of where my headspace is and your thoughts. Alright? Okay, Mona,
Everyone say English as well. English one at that time.
black up there, I don't see it. No, it's black here. Oh, it's
Did she activate your talking about? Because now you're chatting. Anybody like to move on?
Let's split it now.
What?
Those numbers when you get to go around top to the woman to start a vehicle on this big. And it's like, yes, I like it.
You guys understand they can hear what you're saying.
They couldn't hear me saying what you're saying. Yeah. It's not really fun.
Yeah, I don't know if they're getting caught or something. English, math, English. 4 9s. I can't read the others. Or 11 in it.
Yeah.
A lot of schools have the, how you say,
Yeah, you can.
Let me know because I have an exam. For
Miss McCall just coming to me.
you would like that, wouldn't you?
She is. We would like it. See if you would like it.
No, she
We
would.
send different sweets.
He wouldn't like it.
You don't like it because it's Bermuda's not that free. She's speaking of her hands and cries where nobody would even know.
Really not that big.
If we just meet Crystal, we do those things, and then you could see if I know.
You want to go back to this one?
Yeah, 4.
They don't want anybody to see us. And
Which side do you want me to zoom into first? You're going to look small for them.
Oh, yeah, that looks small.
Yeah.
Which is the one interesting? Which is that looks small? The English one, where that maths one?
okay. Alright, do the math thing. That's one.
Alright, zoom in on one then.
And Asha?
Zoom in on that.
Maths?
Alright, afternoon everyone. Bermuda. We're here. Western Jamaica, you hearing me? Alright.
Yeah.
Introductory activity. That's it. Question. We're asking you to use 4 9s in a math equation that equals 100. Understand what I'm saying? Use 4 9s in a math equation that equals to 100. Where you're going to get you have 5 minutes to do that.
What's the minute? 4 9s. 9. Do you times it?
Go on to the equation.
I got 99.
Plus 0.01.
What's 9 squared?
81.
81.
It says use 4 nines in a math equation. It doesn't say you can't use other numbers.
What's that mean?
9 times 9 plus 1 plus 9.
9 times 9 plus 9 plus 9.
Plus 1.
Interesting.
It says
That would
use
give
4
you
nines
100.
in a math equation that equals 100.
So can you use the 9?
St. Lucia.
Say what you can.
Talk to them here and see.
St. Lucia. Wait up.
Yeah,
Alright, you can see the board as well?
I can see Bermuda.
Oh, alright. I'm going to read the question too. The maths question for introductory activity, and it says use 4 nines. You hear me? Use 4 nines in a math equation that equals 100.
Yeah, I have the answer.
You have the
I
answer?
think.
Okay.
I think just a minute.
In 2 minutes.
4 minutes already?
No, at 2 minutes. That's so far.
I can, I'm not math perfect.
Anyone else getting 2 more minutes to finish?
You use 4 no. Last time 1 is 81 plus 9 is 90. Plus 9 is 91. 99 plus 1 is 100. You use 4 nines. 9 times 9 is 81 plus 9 is 90. Plus 9, that's 99. So that's 4 nines. But you use already.
No. 9 plus 9 plus 9 plus 9 plus 64. That's 100.
No, when it's 4 nines alone, one. No other.
4 lines alone was the equation?
Yes.
You don't have the right 4 times.
64.
What is that?
4 times 9 plus 64.
No. Oh, repeat it.
9
Use
times
4 nines only.
So right,
Use 4 nines
9x.
only.
Right, 4 plus 9 equal 100.
No, use 4 nines only. No other number.
4 9.
Okay.
No.
Okay, teacher.
I'm gonna get them.
Let me go get that. 9 times
X.
9 squared.
No.
No other letter, no other number.
Times 9 equals 1. I don't know, look at it. Times 9 times 9 equals 1 is 9. I got it! 9 plus 9.
Can I give my answer now?
Is that right?
Yes.
And that's going to be.
Can I give my answer?
Chris said that. Okay.
Yeah, I'm not to take it off.
All right, everyone. It's time. All right, Chris and Tiana, give me your solution.
99 divided by 0.99.
99. That's so 92.
That's hard.
That's supposed to work. But that's supposed to work.
99 divided by
0.99.
Yeah, that can work. We use that then.
That's what it is.
that is 1 way.
Yeah, one solution.
I tell him I'm checking to goes right.
Anyone else have another solution?
Just one solution there. 99 divided by point.
Can we use indices?
Sure. You can use whatever.
As long as they use only 9.
Okay.
A 99 may get me grief. Teacher, I'm only getting 99. I can't take it.
Alright.
Not even starting the first
I'll show you
one.
my solution. But hard one. You remember this morning, remember the rule bed mass? So you could do something like this. 99 plus 9 divided by 9. Because work out inside the bracket first. So 9 divided by 9 equal 1. 1 plus 99 equal 100.
My gosh.
I'm sorry, I just couldn't get it.
Alright, move on. That's a circle.
That's actually 400% correct.
100%.
Yeah, I didn't use it. He said, he never said he would use that. That's the thing about yeah.
The t-shirt, right?
It's not working like that.
Do a topic called completing the square. Now, I'm going to show you 2 forms of doing this topic. Typically what we want to do is we want to use our algebra tiles to do this topic. Alright, we want to use these algebra tiles. Notice where made them bigger for you so you could see them. But first, before we're going to just show you one of the rules, and then Keezer will show you how to use the algebra tiles to also do this topic. So a simple question would be, how it works, R4x. Which one am I on? Is that x or plus x? Alright. So a simple question be expressed in the form a bracket x plus b all square plus square x plus b all square plus k x square plus 2x. Now, this is normally a challenging topic for a number of students based on the way that it is normally taught. So, for a number of students, in a number of schools, they normally say they start out with x squared plus 2x. Then they always tell them about find half a coefficient of x and square it, and it always confuses a lot of students, right? So, Keys, I want to show them, or you want me to show them first?
No, do them.
Do this, alright. So now what they will do is put this down.
What's that? Oh, Jesus.
Yes. Now I hear some of the students already mumbling what is that on the board. So, easier, show them, for those who do not follow what is going on, how they could arrive at the same answer. What the procedure for it is doing, it says, you look at the coefficient of x. The coefficient of x is 2. The rule says you find half of the coefficient of x and square it. So if you find half of 2, it is 1 and 1 squared, and then we subtract back 1. And then them say that this right here has become this expression. Now for those who do not understand, easier.
Alright, thank you.
Now just before we go on, just remember, we're going to use our algebra tiles. Let me show back again. Whenever a square like this is for people, we're using this style for people who are tactile learners, people who have to touch things to understand who. I mean, your students who, no matter how much time you tell them this, I'm just not going to follow what is on the board. So we are now showing you, teaching you how to learn this topic without following that example. So, right here now, we're going to use this is to represent x squared.
Alright. Good day, everyone. Now, as you heard before, there are 2 ways, or at least 2 ways of completing the squares. Now, you saw one way. Some persons might love it this way. However, I am going to show you another way of arriving at the same answer. First thing is first, we need to know what is a quadratic equation, what's a quadratic expression, right? So before you jump ahead to use these materials, you need to know when you're going to use them, right? So we learned in grade 10 quadratic expressions, right? And Crescentiana, could you remind us quickly how we identify or know a quadratic expression?
When the highest power of the variable is 2.
Very good. Thank you very much. So those are quadratic expressions. Now we're going to be learning how to represent quadratic expressions using our algebra tiles. Now, as Sir told you, this represents x squared, meaning and as we all know how a square looks, right? As how we know how a square. By the way, what characterizes a square again? What must happen for a square?
4 equal sides.
4 equal sides. Right. So we're saying this side is x, is measuring x, and this side is measuring x as well. So that is why it's called x squared. Good. Now here, anybody realize a side that represents x? Which side of this do you think represents x?
The longer side.
The longest side. Very good. And this part at the top here is 1 unit. So 1 times x is x. So this represents x. Also, this is a square here, but it's a smaller square. But what if one of the side measures?
1.
1. So 1 times 1 is 1.
1.
So what I'm going to ask you to do quickly is just to make one big square, one small square, and a rectangle. Very, very quickly. You can do it in groups so that while one person is making the big square, another person is making the smaller square, and the other person and another person is making the rectangle. You are going to need only one square, and you're going to need probably at least 2 rectangles for now. And somebody make about 4 of these small squares. Quickly for me, please. Remember, we are going to be looking at the same example, the first example, using our algebra tab. Can I just show of hands of the group that is finished? Making the tiles?
1, 2, 3.
Yes, miss, we're finished.
Okay, wonderful.
Alright, give me half of my screen.
You're not finished.
Yes.
Let me see.
This is my rectangle.
Alright. So the other group members, you have your, alright, very good, I'm seeing something there. Vicentiana?
Yes.
I know you're working by yourself. Oh, and you have, very good. Wonderful, wonderful. Bermuda?
We have.
How far are you? Okay, wonderful. Now, how do you think you're going to represent x squared plus 2x? Anybody with any idea what you think you're going to do? X squared plus 2x.
One of the squares and then
one of the squares and, by the way, which one of the squares? Which one of the squares would you use?
The large one.
The large one. Good. So we have one of the squares and what else?
2 rectangles.
2 rectangles. Beautiful. So that is how we represent x squared plus 2x. Alright. Now, can somebody tell me what shape I have on the board here?
Big rectangle.
It's a big rectangle. Beautiful. But as our topic suggests, we are supposed, yes, my little bright student, going to obey. No,
Yes.
Right. But as the topic suggests, what shape the topic is talking about here today?
A square.
A square. So we need to make this look like a square. How am I going to do this now? Anybody with any suggestion?
Add another big square.
Add another big square. And that is going to make this a square when we're using what we have here, you know.
No. I don't know. No. What we're trying to do? You need to use another rectangle and a small thing.
We need to use another rectangle, my love. So what about using this one of our rectangles that we have here?
Like that.
We are using what we have. We could, anybody else before I tell you what you should do?
One at the top.
Take one of the rectangles
All
at
right,
the bottom.
take one of the rectangles, yes.
And
you want
put
to
it at the
do
bottom or the top.
right? So we almost have a square here.
Almost.
What you call the other one?
Almost. So what you think is, what would you think we could do to make it look like a complete square?
And a unit.
Very good.
Sorry,
and a unit. Now, what kind of shape we have here now?
A square.
We have a square. We have completed a square. But notice that I had to put this one in. So if I want, remember with equations, with expressions, we don't want to put something in that was not there. So if I added something to it, what do you think I should do to balance this off? Minus. Thank you. So we're going to put this all together now in one expression. Now, what is this length up here? What is this length up here?
X squared plus x.
What is this part here and this part here? Can you
That's
see
access one. Access one.
Yes.
Access one.
Again. Alright, so what is this length here?
X.
X plus 1.
X.
Good.
Yes, plus 1.
And what is this here?
X
plus 1.
X plus 1.
On.
X plus 1. So we have an X plus 1 and the X plus 1. All squared.
X plus 1 plus X plus 1.
Where could I?
Yeah,
Come
you can't sit down for this one.
Unknown. Right? But remember that I had put something here. What is this? What is this representing? This yellow one here?
Unit.
It's a one unit. But originally I did not have a 1 unit, so I have to subtract 1. So
Jesus.
I have an x plus 1 squared minus 1.
So sorry for me.
Now, ask any question you want to ask. Yes, I'm seeing some faces. I'm seeing some faces and you're wondering. But you guys were having fun when we were doing our figure here. So where did I lose you? What is the question? We have an x plus 1, x plus 1, x plus 1 squared. But we had to subtract the 1 because we did not have a 1 originally. And as you can see, the way that we did it first, we ended up with the same answer with the second method. Yes, I'm seeing a hand up there.
Is there another bar up the top too?
If there's another box.
The box. But do you have a rectangle shaped one at the top of the square?
Do you see a yellow?
No,
You see this
no.
here?
On the top, on top of the square, is there another one? No, no, never mind. I have a question. Never mind.
Good. Any other question? Me? Alright, we are going to look at another example. And you will see that it is very, very easy. This time we're going to use x squared plus 6x. 4x.
Commissioner, go ahead.
And
Yeah.
you can choose.
So again, now remember the method that I done, whilst again got the same answers over here. So let us go up the method that I showed you already. You have x squared plus 4x. What is the coefficient of x? 4. Alright. And now find half of 4. What is that equal to? 2. So you can write down then x squared plus 4x is equivalent to x squared. So half of 4 will get 2 and square it.
No, so that one is hard. No, sir.
Well, this is the way that a lot of teachers teach this topic in
That's how you learn.
that's how we learn. And then go down and get this right here. X plus 2 all squared minus 4. We shall write to the roots of the
Alright. Hello? Are we still here? I know
We're
some
still
of you
here.
guys are excited now and ready to try out our new way to see if we can get this answer. So, I want you to go again with your cartridge paper and you're going to represent your x squared plus 4x using your algebra tiles.
I do realize the exact same thing.
So how much of the rectangles are we going to need this time?
4.
4, very good. And how much of the big tiles we need?
1.
1. Very good.
How do we get this?
So do you have your x squared plus 4x on the table?
Yes.
Alright, so
So 1, 2, 3, and 4.
Yeah.
X squared plus 4x.
alright, so we have our x squared plus 1, 2, 3, 4x. Good? Now,
Arantas.
Yeah.
Can I see it?
please sit down. Alright, let's see now.
Arantas detention after.
Okay,
Now, remember, let us keep focused now. Do not be distracted. Now, remember what is our aim again, students? What is our aim? To make a perfect square. But we are having a rectangle on the board. No?
Plus 4x.
By the way, who can tell me what's being represented right here? This is a?
X plus 4.
X plus 4. Very good. And what is represented here?
X.
X. So right there and then you know that it is not a square. So how am I going to manipulate or how are we going to fix this that we have a perfect square? Any suggestion?
Take 2 on one side and 2 on the
Take
bottom.
2.
How you had it, Aaron? Take 2 on one side and then put 2 on the bottom, right?
All right.
Right.
Let us see if we have a square based on what is at the different dimensions. So this, what is this length here now? This is X plus 2, and what is happening right here?
X plus 2.
X plus 2 as well. Good. So we almost have our square, but we need to complete it. Now, what do you think we're going to need to do to complete this?
4 cubed.
4 units.
Right. Very good. 1, 2, 3, 4. So now we have our perfect square.
Perfect square.
Right. So what is it? So we know that our dimension is x plus 2 and an x plus 2. So that is an x plus 2 squared. And what did we add in to complete the square?
4 units.
4 units. But we know that we did not have that originally. So what do we have to do to balance it off now? Minus 4. So who can tell me what will this answer be when I write it down? You tell me what I'm going to write for my
X
answer.
plus 2 squared minus 4.
X plus 2 all squared, yes.
Minus 4 equal minus 4. Is it equal?
Not an equal, we are subtracting.
Oh.
We're subtracting a 4 because
4.
originally we did not have a
There
4.
was no.
We had to put it in to complete the square. So to balance it off, we had to subtract a 4.
No. I see him answer my down there, son.
I'm sorry. Any questions?
Yes, teacher, it's the same thing.
Any question?
No, miss.
So we all understand?
We're trying.
Which method would you rather? Please, by a show of hands, tell me which method you'd prefer to use.
Square.
You prefer the squares. All right.
Yes, good.
Why method?
By the way, this question.
Adrian, that's your method.
This question can very well be in the CXC on the CXC paper this year. So, and you see, we could have actually taught this to a grade 7 student. So I expect you grade 11s to more than get this question right. So what we're going to do. So see that we don't have much time left. You have homework to do. And what I want you, whichever, yes. And remember, you don't have to use no calculator or anything, so this should be fun. I want you to, this is the homework. You're going to complete the square, which is the same thing as expressing in this form. X squared plus 6x. That's all you're going to do. Because I know you have a lot of homework.
Look at that. I mean, it does work in
Everybody understand what they're supposed to do for your homework?
You want us to solve it?
Good. So remember, we have detention for Orantus after class, but the others we can leave immediately. Alright, have a good day now.
Thanks, miss. Later, miss.
Bye. Okay, everyone.
I'm trying to get the F6 one.
I have a feeling that we learned some maths and some English today.
For some strange reason, I did.
Yeah, we learned some math and some English today.
More than so, miss. More than so. First, I seen some of these things.
And you learned, right? So you're not as mystified anymore by some of the algebra and the geometry and the binary.
Binary.
Binary and what we got? Fractions, addition and multiplication and divisions of fractions. So when your children come to you to talk to you about helping them with the algebra, you can remember what? Bedmass, is it?
Yes.
And then you can, even if you don't remember what it is then, you will be able to work it out and show them what to do. What first, what second, what third, etc., etc. All right. I want to thank you for participating today. We have one, I didn't expect for it to take the entire day, but I understand, this is one of the things I'm going to have to process. I understand how challenging it is to be operating in a context where you are teaching using video conferencing, and you have to adjust your methodology to satisfy the needs of the learners in different environments, in different locations. So we're going to talk a bit about that. When I see you on Tuesday, I won't keep you much longer, but I wanted to just, I'll give you my feedback on Tuesday when I have everybody. On Tuesday when I see everybody. And I want to, I don't think I'm going to do all that I want to do with you, but I mean, I'm going to try to get through the critical areas. I have put some readings up that I have said. The PowerPoints on the assessment activity I'm going to set up for you, send to you. The computer's locked out of my email, so I can't get on. Right. But I know why. When I go across to my office, I'll change my password and I'll be able to get on. So before the end of the evening, I'll set the PowerPoints for assessment. There are 3 of them that I'm using. We may not get through all 3 on Tuesday, but you'll get a sense of where you need to think about. One of the things I wanted to do was to help you to write good questions. And I had sent you to a resource by CXC that looks at how to structure your multiple choice and structured questions. So what you could do for me when you come on Tuesday, those of you who will be here, if you could come with a multiple choice question or 2 that you would have developed based on your lessons that you did today. So whatever lesson you did today, whatever your topic was, I want you to write 1 or 2 multiple choice questions that would be related to the lesson topic that you taught today. And you're going to use the information that you should get from the document I sent you to. That would help you to organize it properly. Okay? So I want you to write a question or 2. Alright? When we come on Tuesday then, we'll do some lesson analysis. We'll look at your lessons, we'll look at other lessons, and at least one more. And we will wrap up the course by looking at how everything that we have done tie together and point you perhaps to some more reading material. I'm going to ask you to remember that you still have outstanding for me some things. You have to give me some references. I haven't done that yet. Haven't forgotten.
References for which one?
Micro-teaching as a means of instruction, professional development.
How are we supposed to upload them to you, Dr. Rainford, and review them? Because they still haven't sorted out our...
All right, send them to me. Email them to me.
Okay. Okay. References for micro-teaching.
Okay.
I actually had some.
And I want you to remember that you had a couple of classes ago. We had you did some questions using Bloom's taxonomy. Yes. You wrote. Remember those? I want them for Tuesday. I'm wrapping up everything on Tuesday, so I haven't forgotten.
You want to type them out and send them to you, or
You could do that. You could send it to me, and then I can project it easier, and then everybody can see, so we don't have to perhaps waste time talking through what you can see. So I'll send it to you. You send it to me, I'll send it out. Okay? And I want to look at the business of what is a good reflective evaluation, and we will look at one that I had posted, and perhaps bring another one so we can read through what are the components of good reflection, good reflective writing, so that we can be ready for our final assignment in part 1. Okay? So that's it for today. I'm going to stop now. Thank you again for your participation. I think you did a lot of work, and you all did very well with respect to the micro teaching. You will get some feedback before the end of the day. I will send it to you by email. All right?
Question.
And then I will talk a bit about it. I won't discuss it fully until everybody has finished. All right? But I'll send it to you by email. So have a good evening.
Yeah, good evening, Miss.
Questions, or answer the question.
Sorry, this portfolio one where is do the CXC.org report or CSEC report?
Yes. www.cxc.org.
Okay.
We have to do also this, coordinate on this report too, or?
You don't, no, you don't. You can use, as I have said, any report, any examination report that you have access to. Do you have access to the Cambridge reports?
Yes, we can,
I believe that you should be able to get access to the examination reports.
So what are we going to do? If we can't use CSE, I don't know how to use CSE. Did you read CSE?
Okay?
Yeah, thank you. All right.
All right then. So I'll see you on Tuesday.
Okay.
Okay, bye.
Bye-bye.
She said, I just want to do the lady.
For the last 4 years?
I don't know how to do it. Forward like this. Okay.
Sorry. Everyone's good.
Where do you teach, John? Where do you teach? Okay. In your Excelsior case, in? What's your Excelsior? Is it Excelsior?
Oh.
But where is Jeff?
Yeah, he might get some of the Excelsior. I haven't seen him. He hasn't come back.
Project first. I don't know what it is. Come and to us and stuff.
He just stopped coming. He hasn't come back since. He didn't come back for example for the rest of the day. He wasn't here for the.
I seen come back for one class, but never do. I know so one course, the lady asked, that she said she don't get nothing from him. And so we just asked him to just drop out.
Okay.
After in if you could
Come.
let me go to TSC. I must drop out that then.
I don't think so.
Wait.
I'm going to go there first. I'm going to leave there. Find me with memo.
you.